Hello everybody, welcome by today's live stream. My name is Erik.
And I'm Ruud.
Yes, so today we have a lot of stuff to talk about. Really a lot. I mean, we have some new mainboards. We didn't show you before. In the front you already see the Unify Mini ITX. What is it? Z590 I believe? Yeah.
Yep.
We have today somebody from Intel as a guest. You can ask him all the questions about 11th gen and probably also about a lot of other topics. And we have Ruud here. So benchmark Ruud, or what's your nickname?
Maybe Power Limit Ruud. Maybe?
Power Limit Ruud? Yeah, maybe.
I always
maybe.
talk about power when I'm here, right?
Yeah.
So,
anyway,
yeah.
you know, if Ruud is here, indeed, we're going to do benchmarks. We talk about the best settings, how everything works in the BIOS, etc. And today, you already see the big box over there, the blue big box. That's the 11th gen CPU. I'm not sure what kind of packing this is. I believe the retail. I hope the retail box is smaller. This is the 11th gen i9 11900K we're going to use today for benchmarking.
Yep.
Quite interesting CPU. Also some new features in that one compared to all the other models. That's why we picked this one, or picked, you know. Can we please have one?
We just got this one.
Yeah, we just got this one. Yeah, we didn't have a choice. Anyway, so in the beginning we will do some benchmarks with the 10th gen. Which CPU, Ruud?
Also the 10900K, so the direct competitor or predecessor of the 11900K.
Yeah,
so,
just that we have some baseline, and as you remember a few weeks ago we were all like, I was trying to put the scores on the screen. When was that? A few weeks ago?
Yeah.
Anyway,
Sure
that didn't work well, so now I created a table. We can just put in the scores which Ruud achieves and then see what the difference is.
Yeah.
I see a lot of people already in the chat. 11th gen really an upgrade, depends from what you're coming from. I at home I have like a, I even don't know, but like a 6700 something. Like really old. Yeah, for me it would be a good upgrade. The giveaway, yes. Today we have Assassin's Creed Valhalla as giveaway. So if you want to join, go to msi.com/2/insider. In Twitch and in YouTube we also have a bot. Each 5 minutes it should spam the link. I'm not sure about if it works. I checked it in the beginning. I always do that with ! next week, and it should work. My favorite motherboard. Yes, we read the comment section. And the chat, indeed.
Isn't
okay.
that the same?
Sorry?
Isn't
well,
that the same
no. The chat is during the live stream, and after the live stream is finished, then below, at least at YouTube, you have the
YouTube
comment section,
okay. Yeah.
where people are asking for free stuff, complaining, and also have good questions, feedback. Pricing, we also will talk about pricing today. I will check about the Discord server. Okay, so let's get started. I probably need to fix something. 1 moment. Shall I test if this works? Maybe you can explain a little bit about the specs we're going to use today, the system. Then I fix this.
Okay, well, so we're going to use a Z590 gaming carbon motherboard with a 10900K and a 11900K to see the difference. See the difference in performance, but also the difference in clocks and speed and power and cooling. We're using a Core Liquid K360 water cooler. I think that was in the live stream a few weeks back.
Yes.
And we're also having a RTX 3080 Gaming X Trio, so that's also one of the more high-end cards we have. For the rest, we are using Western Digital Black SN850 SSDs. We have 3 of them.
So those are the new fastest 7 gigabits SSDs.
That's yeah, exactly. It's a very fast PCI Express Gen 4x4 and a second generation SSD. So they are reaching around 7,000 megabytes per second, which is top of the line at the moment. So we're also using a SATA SSD, but that's just for Windows.
Yeah, I'm trying to fix my capture.
Yeah, I don't know what the people at home see, but
The other screen.
they see me.
Yeah, I
Okay,
see you.
yeah.
Me. But I
Yeah,
don't
yeah.
see what I'm trying to...
Okay.
Ah, there it is.
For the rest, we're using Windows 10. We're going to show you some performance in Cinebench, Watch Dogs Legion, Assassin's Creed Valhalla. We're also doing some disk benchmarks to show you the difference between Comet Lake, like the 10900K versus the 11900K. In the slides, there will also be information about that. We're going to show you about the memory speed difference between the 11900K and the 10900K, and also the settings that come with that in the BIOS. Unfortunately, we couldn't get the second capture card running, so we're using NDI on, so that's like a software stream.
Yeah, I think most people who regularly watch us, they know.
Yeah.
Indeed.
So it means we cannot show you a live the BIOS settings as we
Well, maybe
would
with
have
the
liked,
webcam.
but we do have a webcam, so we can aim
Yeah.
it at the monitor and show you if that's necessary. We will do it, no problem.
Okay, I will increase the volume a little bit. Okay, so let's get started. I got the NDI capture to work. So let's first talk a little bit about our lineup. These are our MEG motherboards. The models I highlighted in red are the models we're going to talk today about. The Unify, we have a sample of that one. The Z590i Unify as well. Godlike and Ace we already showed you earlier. So these are all the high-end motherboards, also for more performance, more features, beefier VRM, overclocking also, depending on what CPU you use. Then we have the MPG models, which means MSI Performance Gaming. These models we have the Gaming Carbon. The Gaming Carbon is actually the test platform we use today.
Yeah.
The Carbon EK, I didn't have a sample of the Carbon EK yet, but it's also interesting to have a look in the future on that model. So the Gaming Force, the first time we have it here, but we have a sample which is not 100% complete. Still want to show you that one. Z590 Gaming Edge Wi-Fi, Gaming Plus, and the Micro ATX. And this is one of the few Micro ATX Z590 models we have in our lineup. And you will also see that from other vendors, that for Z590, most will be ATX, because everybody wants a lot of features and you have a lot of PCI Express lanes. So everybody wants to use that as much as possible. Then in our oh, that's the wrong. I have like 3 keyboards here. In the MAG entry-level gaming segment, we have Tomahawk and Torpedo. And then we don't have any content creation for this. Normally content creation, we will make motherboards which can use like the high-end desktop platform from Intel with like 24 to 64 cores at this moment. So that's what you generally find on X299 on Intel. And then we have the Pro motherboards at this moment. We have for ATX the Z5, sorry, not for ATX, for Z590. 2 models, the Z590 Pro Wi-Fi, which comes with the Wi-Fi, Intel Wi-Fi 6E. And then Z590A-Pro. They don't differ much, a lot in specs. The biggest difference is Wi-Fi and some small other details. If you want to know about all the models in black, I would say 90% of them we already covered in previous live stream. The first live stream we did on the 13th of January was the launch, right?
Yeah, somewhere in January.
Yeah, indeed. So same for the B560 lineup. B560, the mini ITX we have today. Ruud, can you maybe show that one?
Oh, we have that one here. You want to have a close-up one?
Yeah. So later we're going to talk about this model, all the details. Let's go back. Then, I mean, B560 is cheaper, which has less features, so you automatically don't get all the features, and that's why B560 normally you find in the MAG segment. It's kind of logical. Tomahawk, Torpedo, Mortar Wi-Fi, Mortar and Bazooka. And then on the Pro segment you see a lot of B560 micro ATX models. And this is typically used in office PCs or in, the people who don't have a lot of demands for a lot of features. So you typically see 1 or 2 PCI Express slots. PCI Express slots and or 2 slots. Not so much fancy audio, just the basic stuff. It's still called the mainboard, don't worry. If any questions, just drop them in the chat. Yes, we have a guest today. Somebody from Intel will join, but he is from Intel USA team, so I hope he's still sleeping. It's probably like 6 or 7 o'clock in the morning over there at this moment. So he will come, don't worry. H510 at this moment 3 models. H510 is it's a cut down version. If you look at the chipset, it doesn't have all the features. Later with Intel we're also going to discuss the differences in all the chipsets. So if you have any questions why they made a certain decision in their design philosophy, just ask. You can ask everything. I mean, we don't have time to answer everything. Our focus will be at the 11 gen and at the 500 series chipset. Just put it in the chat. The microphone of Ruud is very low. No, Erik is shouting very hard.
Yeah, I can also move the microphone a little bit closer to my mouth and hopefully it's better.
Ruud!
Yes.
Yes, sounds better.
Maybe I should talk a bit louder like Erik.
I'm not talking, I'm always shouting.
Yeah.
Okay, so we already talked about this before. Z5, each generation we're learning, we're making improvements. We're checking all the comments, what you guys are putting in the forums, what we hear, for example, Newegg, Amazon, all those stores. If you want, you can leave your review behind. I hate this mainboard, this sucks. Can I say sucks? Yeah, I can. I love this mainboard because this rocks. So we are checking most of those comments and we're acting on it. So we're learning from your feedback. We're checking, of course, reviews from the media, but also our customers, system integrators, etc., what feedback they give. So each generation we try to improve. If you watch this live stream regularly, you already know it's not that simple. Our team, we're doing product marketing, so it's our job to always take this feedback to the R&D PM so they can work on this. But it always cost involved. Sometimes we're not realistic, like, hey, if we can do this, it would be very cool. Yeah, but it will cost €100. Supply issues. I mean, we need to have several vendors who can supply it, because if otherwise the supply dries up, you now have a lot of supply chain issues. I'm sure you know about that, you heard about it. Then the whole product with maybe, 1,000 components on the motherboard, we cannot deliver. It needs to fit the price segment, it needs to fit the generation, we need to have time for it. If it involves software or BIOS or something like that. So, yeah, always, it's a long process. We're already working now on the next generation motherboards. I cannot tell you about what it is, doesn't matter. But all the feedback we read now, all the things we see in the chat, we're trying to bring as much to our R&D PM so they can think about it, study it and improve on it. And it doesn't mean we can fix everything like what I just said, but at least we're listening. So these are the things. We did all power stages on all the Z590 models. 2-ounce copper in the PCB to have better PCB cooling, a better PCB, and this is also necessary with the PCI Express Gen 4 signal. We switched, Intel LAN, in the last generation we used Realtek LAN, and that had a reason, because the first generation of Intel 2.5 gigabit LAN, actually the first and the second generation, they had some huge issues, security issues, etc. And now the third generation, which we are now using on Z590, that's completely fixed. So we also switched to Intel Wi-Fi 6E, Bluetooth 2.5 comes with that. It's in the same module. We also try to expand on the number of M.2 slots, and sometimes it's tricky because, of course, you always depend on the number of PCI Express lanes which the chipset offers. So sometimes we have to make it switchable. You will see later on the mainboards what we did. HDMI 2.0 is more important, and BIOS flashback button, since those BIOS updates, they keep coming, right, Ruud?
Yep.
I mean,
this week already had 2 BIOS updates.
Yeah, there's 2 BIOS updates for Z590.
Yeah.
Yeah, so if you look at the AMD, for the BIOS flashback button was normal on AMD because, you know, it was the AM4 socket is a long-running socket, and yeah, I mean, each time you need to have a new BIOS code in order to run a new CPU. And if you buy a new mainboard and you put the, you know, these mainboards also ship, you know, they are in the warehouse somewhere. It takes time to get them in your hands. It's possible that meanwhile a new CPU was launched, which you buy, and there is still some old BIOS code on, and it will not boot. So that's BIOS flashback button. You just put a USB key in with the BIOS, without power, without CPU, you can flash the motherboard.
You do need to have a little power.
Yeah.
Yeah.
Where's M.2 PCI Express 4.0? We will show you.
Mm-hmm. Yep.
You're welcome. See that, peeps. He won a game code a few weeks ago. He's enjoying the game. Good to hear that. So one of the things, and this is with the 10th gen CPU. Later we will talk about power usage and temperatures with the 11th gen CPU. But of course is the heat in the VRM. VRMs are nowadays very important. That's also why we improved a lot on that, because of the heat, the cores, the speeds the CPUs are generating and using. So this is an example on our Z490 A-Pro, one of the entry-level ATX motherboards, versus the Z590 A-Pro. And what you can see here with a 10900K at 4.8 all-core. So Ruud, what is normally the...
that would be like the normal Turbo Boost 2.0.
Yeah, that's why I have Ruud here. He knows all this kind of stuff, all those small numbers.
Yeah. Most of them, yeah.
Most of them. Okay, so here you look at temperatures like 115, 121 on the back, and the heat sinks are close to 80 degrees. And on the new mainboard with the same kind of CPU, you're talking about front 84, so that's a big decrease. Back close to 90, and the heat sinks on top of the mainboard are 68. Yeah. So that's also more than 10 degrees difference, and that's percentage-wise a lot. So that is one of the goals. The VRM, of course, needs to keep running cool in order to still provide the CPU with a lot of power. And these, you know, the last generation CPUs, everything gets more power hungry. That's a fact. I mean, you have more cores. You sometimes are still on the same production process. We will see that also today with Intel. And higher frequencies, higher boost clocks. So basically, and that's what Ruud is going to demo to you, with all kinds of the BIOS settings and stuff, the current architectures are just booting to what your cooling can cool. Am I saying that correctly, Ruud?
You have to select what kind of cooler you have, so you will have a matching power budget.
It just keeps going.
Yeah.
Let me check the chat a little bit. The main question. PCI Express Gen 4, no, you will not have any compatibility issues. This will all work fine with PCI Express Gen 3. It's backwards compatible. Yeah. In case you have any issues, you can always go to the BIOS and switch it back to the previous generation. But everything is tested. That is industry standard. Should not have any issues.
We're also running now Gen 4 SSDs in a Gen 3 slot. So the slots attached to the PCH are Gen 3, and they just run fine. It's like standard Gen 3 or Gen 4. You just have the speed of Gen 3 at that moment.
Yeah, indeed. So let's first talk about this model. We showed you already a render earlier. This is the new Z590 Unify motherboard. So Ruud, you have one, right?
No, I have one, yep.
So,
let me adjust it a little bit.
Yeah, so for people who know about Unify, the idea behind Unify is very simple. no RGB. Well, actually, you know, there are some pin headers for RGB, but it doesn't have any RGB LEDs. So completely black. It's a MAG motherboard, so quite high-end. This one comes with 3 M.2 slots. They're both covered with shield frozzer. They're all 3, I should say.
One here, that's a thick one. Another one here, another one here.
Yeah, indeed.
So you can remove those covers by unscrewing those.
We already talked earlier about that. Cooling the SSDs is very important because with the Gen 4 and with the high frequencies, the high speeds, they can get very hot. And if you cool them with these kind of heat sinks, and that's also why some of the SSDs come with a heat sink, you can delay the throttling. I never claim that we can prevent throttling. Oh, Ruud? Should I say delay throttling?
Depends on the SSD as well.
Yeah, indeed.
Normally the SSDs won't throttle at all because you need to write multiple times the total capacity after one and after another. So it's not really a realistic scenario. Only in synthetic benchmarks you can get it to throttle without heatsinks. Yeah.
So if we look at this motherboard, the Unify, there are 2 versions of it. We have the normal MEG Z590 Unify, and we also have the MEG Z590 Unify-X. And the -X is almost identical, however, it's a different PCB and it only comes with 2 DIMM slots. And that model is especially targeted memory overclockers, and that model we don't have it on hand yet. So actually, I think it's not back from the factory. So you will see that in like a few months' time, I should say. This model has Intel 2.5 gigabit LAN, Intel Wi-Fi 6E, comes with audio boost. Also, Ruud, maybe you can show the back of this model?
Yeah, sure.
No, yeah, no, well, yeah, I mean the back I/O back.
Oh, that back.
Yeah, that back.
Sorry.
Yeah.
PCB back or I/O back. Yeah.
So a lot of I/O of a lot of USB ports. It's also what we try to do, and that's not always easy. But we try to populate the I/O part with a lot of USB ports. I mean, of course, this one has also USB 20 gig, so that's the Type-C connector. Ruud, can you maybe point that one? Yeah. No. Yeah.
It's
that one.
mirrored for me.
Yeah, that's so that's a USB 20 gig. Later we will do some benchmarks, and you will see that the performance of the Intel 20 gig, USB 20 gig, I should say, is much better than the S-Media 20 gig. So this is the first generation Z500, of let's say the 500 series. Which Intel built in the USB 20 gig, and yeah, if Intel is doing something, then the performance is always top notch, and we can prove that later. So the top port, it's written there. The LAN port is 2.5 gig. It says there it comes with Wi-Fi. In the box you find 2 Wi-Fi antennas. Actually, it's 1 Wi-Fi antenna with 2 cables on it. HDMI out. So if you want to connect a monitor on the integrated VGA, you can still do that. On the left side, the 2 buttons, Ruud, can you point them?
Yeah.
Yeah. So those buttons, one of them is the BIOS flash back button, and the other one, the bottom one, is the flash BIOS button, and the top one is a clear CMOS button.
Yeah.
So let me check the chat.
They want to know about how many phases does the Unify have.
This one has a 1690 amp VRM design.
So you can see the chokes over here and over here.
Yeah.
And of course also you will see the back with some heat spreaders as well on the back of the MOSFETs, or power stages I should say.
Yeah, this is a demo board. It's not working actually. That's probably why we got it, because this model is not yet MP. So it's a dead sample. So unfortunately today we cannot benchmark with it. But at least we wanted to show you this. So I'm going back to the... yeah, so here you see all the features of this motherboard. This board was the Z590 Unify.
I think that's a very nice looking board, and also one of the most anticipating boards for Z590.
Yeah, very clean indeed.
Yeah, but also,
This one does not have a Thunderbolt connector, but instead it has USB 20 gig connector. Let me talk a little bit about the VRM design. So if you remember Godlike, Ruud, you also have Godlike over there, right,
yeah,
in the box?
I do. Yeah. Hang on.
I gave Ruud like a big box with like 6 or 7 motherboards. Let me see, detailed view, yeah. So this is the...
it's a mirror one.
Yeah, it's a mirror one. So this is the Godlike model. We already talked about it in a previous live stream. However, this model...
Sure how to...
Yeah, it's okay, Ruud. So this Godlike motherboard has a direct phase. And if we talk about the models you see listed here, so the Z590As, Unify and Unify X, they have a 16-phase 90 amp mirrored power arrangement. So that's what you see here on this chart. So and that's to ensure clean power delivery to the CPU, of course. And that's also for overclocking. Then we're going to talk about Z590i Unify Mini ITX. Ruud, you had it there, right?
Yeah, this is at the front.
So it's the...
It was hiding my cables, by the way.
Oh.
Oh.
Can you maybe put it next to the Unify board?
To the edge. Edge and Unify, you mean?
No, to the ATX board.
Oh, the ATX Unify. Oh, sorry. Yeah, sure. Oh, I can do that. Both are Unify, but slightly different.
Yeah, indeed. Both are Unify. This model, it's Mini ITX, so that means you have limited space. Still, our R&D PMs were able to put in 2 M.2 slots. So they're like a piggyback, right?
Yeah, piggyback or like a sandwich. Yeah. So there's one underneath. There's another PCB over it, and then there's a heatsink on top of that one. Yeah. It's hard to see with PCI Express by 16 in a way, but yeah, maybe you can just look at it. Maybe a different angle. So on the bottom there's also one, and then there's a PCB with another one.
Yeah, so this motherboard also comes with 8-phase 90 amps VRM design, so it's really powerful for such a small board. Normally on a board like this, you use the Dr. Moss because of the small PCB size. So you don't have a lot of PCB size to make a big VRM. So that's most of the times logical choice. If you look at the back I/O, I should say I/O. Yeah,
I/O. Yeah.
I/O.
I know I/O.
Yeah, then you see over there Thunderbolt. Ruud, can you point them out?
Yeah, Thunderbolt.
And 2 mini display ports. So this is Thunderbolt 4, which also comes with USB 4. Later with Intel we're going to talk about this. And quite interestingly, you don't see this on a lot of other models with Thunderbolt. You also have mini display input. So which means that if you have a VGA card, let's say discrete graphics, you can connect them via DisplayPort as to these display inputs. And you can use them for your Thunderbolt. So a lot of times this is not done, and then you lose half of the functionality of your Thunderbolt. So on the left side you see HDMI, DisplayPort. This one does not come with USB 20 gig. That's always a trade-off. Either you have USB 20 gig or you have Thunderbolt 4 on these boards. Also on the left-hand side you see a small, I think it's a clear CMOS button, right, Ruud?
This one is clear CMOS. This one. Yeah.
Let me see the chat. A lot of questions. Does the bottom M.2 have any cooling?
Yeah, it does. It has a metal heatsink.
Maybe Ruud, do you have a screwdriver?
I do.
Uh-oh.
Here we go.
Shouldn't have asked.
Of course you need to unscrew it. I haven't unscrewed it before, so never know what to expect. Let me adjust the camera a little bit so you can see what I'm doing. Okay, so the top heatsink comes off. Then there's the first one. It's not focusing yet.
Yeah, I'm going to try to fix that. Not deactivate. That's the wrong button.
I can just show you. So this is the PCB for the top one. I can unscrew that one too. So just see how that goes. And then there's a connector. So an interesting connector. It's I think I haven't seen this one before. Maybe I can show more close up.
Yeah. So and then there is
this
a
one. Yeah.
Yeah, and then at the bottom there is also a cooling strip.
Yeah, there's a cooling strip, but there's also a big metal plate underneath. So there's a protective foil over it. So and then there's a thermal pad. I can feel, you can just press it. It's flexible. And then there's a metal, aluminum heatsink underneath. So that's cooling the bottom one. And but I don't see the second slot yet.
Which one?
I think, oh, it's on the bottom. It's so basically the two M.2s are on either side of this piggyback board.
Yeah.
So one on the top, so it's hovering over the PCB. The other one is lying very close to the PCB and is upside down, clicked on the motherboard, so like this.
Yeah, and with this Z590i Unify, you can build a really powerful small mini PC.
Yeah.
Comes with all the features, also Intel 2.5 gig, Wi-Fi, Thunderbolt, like what we talked about, 2 times M.2, what Ruud said. Let me switch back.
Okay, then I'll put it back, screw it back.
Like
Otherwise
this.
we'll lose some screws. And
They have all that the information. Let's continue. Well, this one also comes with 10 layers of server grade and 2-ounce copper PCB. And this is important because it's such a small mainboard, and then you don't have the servers to spread out all the signals. You still need to make sure they don't interfere, so that's why this one comes with 10 layers, which is even 2 layers more than what you find on like the ATX Unify or Godlike or Ace, something like that. The entry-level motherboards have 6 layers, and the gaming motherboards have 6 layers, but they also come with a server-grade PCB. And a server-grade PCB is to ensure better signal for higher frequencies. Then you talk about memory overclocking and this kind of stuff. This Z590 Unify, now we can talk finally. I mean, we did already 2 live streams. One was on the 13th of January about Z590 motherboards. One was, I think, like a month ago, I don't remember anymore, about B560 and H510 motherboards. And each time we could not talk about performance. But yesterday, finally, Intel launched their 11th gen CPU. So today we can talk about performance. And this is two world records. At the bottom you see there 2 world records, number 1 and 2 are both created with MSI. And the top one, the top one with 3507 8.2 memory frequency, which actually is doubled. Because that's how DDR4 works. So, and when it's double, it's more than 7,156. 56 in English, yes. DDR4 frequency. So that's 2 world records for MSI, and these are both created with this Z590. Well, not with this one. I mean, we got this one here, right?
Yeah.
With the Unify mainboard. So, and our ATX Unify 2DIMM. So ATX Unify X-X still has to be released. So that will probably means we can increase the world record. But that's for later. Buffering. Make GPUs. Well, yeah, we can only make GPUs. We don't make GPUs, we make graphic cards. And for that we need GPUs, and for that we need other components. Everybody waiting for VGA. Yeah, you saw that big ship which was stuck in the canal? I'm sure a lot of GPUs were on there. Or stuff from AliExpress, that's also possible. Nobody knows. Then let's talk about another B560i motherboard. This is the Gaming Edge Wi-Fi. You also have that, Ruud?
Yeah,
Where did I put
we showed it a second ago.
Yeah, So this is same size, but it has not all the same features. So we're talking about Realtek 2.5 gigabit LAN. Still, it has, I think, Intel Wi-Fi 6E. Comes also with 2 M.2, but one of the M.2, Ruud, I think it's on the back.
On the bottom, yeah.
Oh, now you say bottom. First I said back and you were checking the bottom.
Back or bottom?
Yeah, anyway.
Can be anything, right?
Yeah, so that's where number 2 is, and then number 1 is on the top.
On the top, yeah.
Yeah, it's covered with a heatsink.
Yeah, we can unscrew that too if you want.
Yeah, sure.
Sure.
Yes, Cloudy, we all are. Well, not all, but Ruud and me.
Yeah, we're Dutch, yeah.
Yeah. So, well, if you place the M.2 SSD on this motherboard on the back or bottom, whatever you want to call it, you of course need to keep in mind that this is the SSD you don't want to remove often, because otherwise you have to remove the complete mainboard depending on your case. Because some newer cases, they already know this kind of designs, because it's not the first time we do this, and they have an opening where you mount the mainboard, so you have easy access. But that's not in all cases, so you have to watch out.
Yeah, depend on the case.
Yes, we're going to show Gear 1, Gear 2. We're going to live benchmark it. We're going to show you how it works, what the benefit is, and that's all Ruud's job, technical stuff.
If we have time, because Eric should speed up, I guess.
Right? Yeah. I'm going to speed up, so I'm going to show you this. So this is the Gaming Edge Wi-Fi. We already talked about all the features. Also has extended heatsink. Most of you know what it means. Basically, better, bigger cooling. Again, only 2 DIMMs and 1 VGA card, but I think for most people that's enough. And this is in a different price category than the Z590 I Unify. There's also a different chipset, so you don't have the overclocking features, so you don't need all the VRM options. And this also doesn't have the 10-layer PCB. Let's have a look at the last model we didn't show you live yet. And this one, well, they sent us a sample, but I think they forgot some parts. Detailed view, Ruud. Yeah, so this is the, like that. This is the Z590 Gaming Force. It looks more or less like the Z590 Gaming Carbon. It has similar features. It has premium cooling, comes with a duet rail, 16 times 75 amps SPS stages. So audio boost 5, 2.5 gig LAN, and as you can see on the, let me go back, Ruud. Oh yeah, we can talk about the back side. What do I see? I see USB ports. I see USB 20 gig, the Type-C connector. No, yes,
yeah,
indeed, USB 20 gig, 2.5. I think there's Realtek LAN on this one. USB 10 gig, I think the blue ones, Ruud, or the red ones?
The red ones are probably 10.
Yeah, and the blue ones 5.
The blue ones are 5, yeah, exactly.
Indeed.
And the black ones are USB 2.
Yeah, indeed. So that's this model, and as you can see here on the picture, it has the heat sinks. They will ship them to us, and I said, well, I mean, they will not arrive on time for today's live stream. So may the force be with you. Correct. Indeed. So also has nice RGB, but yeah, we don't have time to show that today. We will come back to that another time. Let's talk a little bit about pricing. Because yeah, I know this is not a popular topic, because everything is really expensive. You all know the reasons for that. I mean, also if I have to buy stuff, it's expensive. No different than for you guys. So yeah, it's these are the prices, MSRP in US dollar, excluding VAT, because each US state decides the VAT, and Europe, of euro, I should say, the MSRP including about 20% VAT. It differs per country. Some have like 26, and some have maybe even still 17 or 19 at least. So at least you have an indication. And I'm also going to show you the pricing. Just make a screenshot, or you can watch back later. I'm not going to run through each model. Again, price indication means it can be way more expensive and it can be way more cheaper. It's just a price indication for you, that you have some guidance on what to expect in the market. And for sure, it's always very simple. In the beginning, items are all, let's say, new products are always very expensive, and the more stuff comes on the market, the more mass production there is, and the more saturation there is in the market, and each shop they have stock, and the big demand in the beginning, like, ooh, I want Z590, or I want like 3090, the GPU, RTX 3090. Then normally it will, the prices will go down, but now with all the container shortages, the supply chain issues, I saw the US dollar is also getting more powerful, I should say, so more expensive. All plays into this. So we're not going to say next month you will see cheaper prices. Normally, we always said like in a few months' time, price will go back to normal. At this moment, a lot of people expect that high pricing will still continue this year. Besides the pricing, in different regions, we are also running some channel promotions. USA, we have a mail-in rebate. I'm not really familiar with the concept, but basically I think you prove like I bought this mainboard with the invoice, and you get like a discount depending on the model. So if you're based in the USA, just go to USA. I think it's like USA or US.msr.com. And you will find this landing page on which you can find all the details. But depending on the model, you can get up to $75 rebate for the Z590 motherboards. Additionally, you can get some Steam vouchers with shoutout. So shoutout is an action we're running worldwide, and with shoutout, it basically means if you leave a review at a store, so like Newegg, they have the eggs. I give you like 1 egg or 5 eggs, and you leave behind what you think about the product you purchased, you can get some extra Steam vouchers. And we don't care if it's negative or positive. I mean, we care about your feedback, because with your feedback we're learning, and we're learning to improve our products. Europe, we're running cashback. I think it will start like tomorrow or next week, not sure. Tomorrow is April Fool's, Ruud. Yeah. Maybe not a good date. Anyway, this will start soon, up to $105, depending. And actually, sorry, this is a combination of Z590 or B560 combined with one of the MSI liquid coolings. So it's a bundle, and you can get. That's why the amount is also higher. You can get up to 105. Let's say US dollars, maybe it's euro, but let's say US dollars rebate. And also you can participate in the shout out for the Steam vouchers. APAC and Indo pack, so basically, a lot of countries in Asia. Z590, B560, same with the liquid cooling, up to $100 and and that is in Steam vouchers, and that all has to do with the different regions. And please check your local MSI product page, because on that one you can find all the details for this. And if you're like Latin America, it's not listed here. We also have some actions, I think starting in April or May. Not sure about the details, but each action of each region is running some actions. So yeah, Ruud, I'm trying to hurry because Ruud wants to do benchmarking on the 10 Gen. So this is the platform we're using today. The specs are on the left side. So this is the motherboard. It doesn't show RGB today, right? Because you don't care about RGB and you want to benchmark.
I didn't install the software, but
like that.
I used the motherboard before, and I just set up the Mystic light, and apparently I've left it off in some kind of purple color effect.
That's
so
okay.
Basically it's just stuck in that, except for the graphics card is a different one, so that's doing its own thing, and that's doing the default rainbow effect. Yeah,
so let's talk a little bit about resize bar support. What's the different name?
Resizable bar is the official name, and you have the Smart Access memory
Smart
from
Access
AMD.
memory. For AMD indeed, yeah. So NVIDIA, Intel launched yesterday 11 Gen CPUs. NVIDIA also launched the resizable bar support for the 3070, 3080 and 3090. Because 3060 was already released. So for MSI it works on AMD 3000 and 5000 series because 4000 is APU. In a combination with either the 400 series, 500 series or X399 or TRX 40 platform. And for Intel it works on the, actually it doesn't really depend on the CPU, but 10 gen, 11 gen. And then selected 300 series models. So not all, but all 400 series, 500 series and X299 maybe also series. So if you want to enable this, we already talked about it in the past. Because I'm hurrying a little bit so Ruud can do live benchmarking. Just go to your BIOS, enable resize bar support. Automatically the above 4 gig memory decoding, or let's say cryptocurrency mining, will enable as well. And that's how you set it up. You need to have the right BIOS in order to see this feature. You need to have the right driver from either NVIDIA or AMD in order to support this. You need to of course have the right CPU, GPU. Because not all GPUs supported on AMD, you need to have the right CPU as well. And the number of games are really limited at this moment.
Yeah. If you have a 3070, 3080 or 3090 from MSI, you can update your V-BIOS by going to live update. So just go to the website, download the live update program, or use Dragon Center. The live update function is also in that one. So go to advanced, and advanced will show you if there's a motherboard BIOS update or a graphics card BIOS update available. And if your graphics card supports it, then it will offer the latest V-BIOS, and that will make it possible to enable resizable bar in software as well.
Yeah, okay. So these are the benchmarks we're going to run today. So first we're going to do resize bar. We're only going to do that on the 10900, which Ruud now has installed in his system. The specs of the system machine on the left side, we can run it on 11900K, but I mean it will be almost identical.
Hopefully we have time now, so yeah, let's do it now.
So Ruud, you have 10 minutes.
Okay.
We're going to do some Cinebench marks. We're going to measure power usage, game benchmarks, Watch Dogs Legions, Crystal Disk Mark for Gen 4 and Gen 3, and the DMI. That's also an interesting topic. Some memory benchmarks because Gear 1, Gear 2 stuff, and Intel ABT. And what that is, you will see later. And some USB 20 gig. Should it be G? Yeah, probably. Anyway. So Ruud.
Now, first we'll run with the...
Does the capture work? Probably not.
Not yet. You still have an old picture, I see, but I'm in the BIOS at the moment, so I'm going to enable
in the BIOS?
Resizable bar right now.
Oh, if you're in the BIOS, then not much I can do.
No, so, not yet, but...
I'm going to do a giveaway. It's overdue. You can continue, Ruud, and just let me know when...
The resizable bar is not enabled by default, so you have to go into the BIOS and enable it. Of course, you also need the V-BIOS of the graphics card to be updated. And once that is in place, then the graphics driver from NVIDIA will show you if it's enabled or not. And it's really easy. I will show you in a minute. System Windows still booting.
Okay, so... sorry, Ruud, let me interrupt you. We have two winners. I just draw two winners. We have the first one is NightJ10TX. Congratulations. And the second winner with the loyalty bonus, good stuff. Titanio. I hope I pronounce it. Yeah, well, that will be for all names. I mean, Titanio. Anyway, both of you will get a Assassin's Creed Valhalla game code via email in the coming days.
Okay, can you check if the NDI is working here?
Yes.
No, that's not the screen I'm having.
No, I know, but this should be, yes.
I'll click to the NVIDIA control panel. If we see it pop up. Yeah, that's good, all right. So I've enabled it. And so you can check yourself by going into the driver and then click on system information, and then you will see resizable bar saying yes. If it says yes, it's enabled. If it says no, it's not. So let's, there are several games that respond well to the resizable bar. There are some games that don't respond at all, so there's no improvement, and also no decrease in performance. And some have slight disadvantage with resizable bar. It's still very new. Drivers are new, biases are new, so maybe games also need to be fine-tuned for it. So what we saw was Valhalla was one of the better titles to show some performance uplift. Let me see. We can launch that one. It takes a while to load.
Yeah, so I always say, you know, the performance for resizable bar or SAM is for free. You know, just do a BIOS update. Maybe you need to flash your VGA, your GPU as well, depending on which one you have, and you get like 3 to 10%. Ruud, can I say that on average?
Yeah, 10% is
no, that's not an average, but like 3 to 10.
I would say it's 0 to 10% because it can also be 0.
It can be negative.
Can also be negative. Yeah.
So and
depends also on the settings a lot. So.
Indeed. Yeah. So I'm sure a lot of you will see a lot of media still testing with this, diving into it to find out when it's, you know, if it's resolution dependent, because in different resolutions the performance will differ. If it depends on CPU bottlenecks, at this moment very difficult to say, but yeah. You just get free performance, and that is what I like.
Yeah, what we saw mostly is that there needs to be like a lower setting. So, for example, the resolution has to be low, like 1080p, or it needs to be like very simple settings, like medium settings, not ultra, because then it's very GPU limited, and then there will not be any benefit from resizable bar. So the higher your settings, the less improvement, and the lower the settings, you will see some improvement. So, but it's like Eric says, it's for free, so why not enable it?
Yeah.
But it's still manual, so you still have to enable it manually. So, I also saw some editors. They say, okay, it's not enabled by default, so we're going to test everything without. Depends on point of view, I guess.
Yeah, I think this will also. So you're now running a benchmark with or without?
This is with.
Okay. Yeah.
And then we'll move to without because that's the default. So,
yeah. So I think this also will depend on the maturity of the resizable bar or SAM, whatever you want to call it, this technology, because now sometimes we see that some scores are negative. So with resizable bar you perform less. And I think, like NVIDIA and AMD, they can easily block this in the BIOS. In the driver, or they have to optimize together with the game developer. They have to optimize the game more to benefit more from this. So this will all take time, like with all new technologies. Yeah. And I think that will be the moment that we can decide to enable this by default.
Yeah. Actually, I had a different order planned. So resizable bar, what was my last thing to show, but since you brought it up, I'll just do it at the front.
Yeah, I moved it to the front.
I think it's not the most interesting part of what we're going to show today.
Oh, no.
So.
You mean the stuff with the fire and the smoke?
Yeah, hopefully that won't happen again. So we're going to have 128 frames per second in 1080p medium settings. So that's a bit lower than I expected.
NDI?
I think. Yeah, NDI is also in the background, so it will take away some frames, but yeah, we'll make a screenshot and disable it and see what we get.
How to get the bonus? The loyalty bonus in the giveaway, the more you join, the more you watch our live stream weekly, the more times let's say after like one time you get an extra point, or let's say the second time you get an extra point, after 10 times you get extra points, etc, etc. Yes, I ruined Ruud's plans, but it's always like that. I mean,
yeah. That's
we
okay,
we
that's
had
okay.
we have too many topics today which we want to show you, and the platform just launched, which also means that we are still figuring out a lot of things.
Yeah, yeah.
Like ABT is just a new technology from Intel, released a few weeks ago to us. We were
Well,
developing.
last week.
Yeah, well, not to us, like to MSI a few weeks ago.
The
But
BIOS I got was last week.
yeah, but
Yeah.
then they need to implement in the BIOS,
Yeah,
and then you get the BIOS, and then you can play with it.
yeah,
And yeah, I mean, this is a new technology, so we still need to figure out a lot of stuff. What's the best optimal setting?
yeah.
And Ruud said this morning, he said, I think I'm just going to say this, and we're going to ask HU to change it like this, because I think this is the best setting.
Yeah.
So and that's normally how we also work in product development, is just testing, figuring out how stuff works and what it does, and then feedbacking this to optimize the BIOS or the driver or the hardware.
So as you can see, resizable bar says no now. Just
Let me see.
disable. Oh,
Sorry, Ruud.
sorry, I already clicked it too fast. No.
Yeah, no.
Okay. Oh, you don't see my cursor now, right? NDI is doing the reset thing every time.
Yeah, but I have the zoom function, so.
Oh, okay, okay, no problem. Let's do Valhalla. See what 128 we had, right? We also saw that AMD graphics cards seem to have more benefit from resizable bar than the NVIDIA graphics cards, but for NVIDIA it's very new. AMD already anticipated on this for a longer time, so probably it has matured more for AMD than for NVIDIA. Or the games need to be optimized for NVIDIA as well.
Yeah.
I don't know.
Or it depends on the CPU. I mean, there are so many factors. And that's what I said, you know, it's still a lot of new technology, a lot of testing before we can decide.
Yeah.
This will be default in the BIOS.
Yeah.
And even then, Ruud, you know, sometimes we have concern from system integrators. We want to change something for like the gamers, and then they say, better don't do it because system integrators want this and this and this.
Yeah, some people they still like to play with old stuff. So
The 9084 BIOS.
yeah, no, but also some we still get questions. Can I run Windows 7 on it? I haven't tried it even, so yeah, I don't know. So yeah, you can buy one and try, and yeah, but it's not tested, that's for sure.
So I'm going to try to add Alex from Intel USA.
Yeah.
So Ruud, you can just continue with your benchmark.
Yeah, I'll just press benchmark and click yes.
Early bird.
I don't know if we can continue benchmarking and you can show like a small window of the results, and everybody's seeing that we're doing the benchmarks live. Then we don't lose time and we can still have Alex do his presentation. Something like that.
Okay, I'm going to try to do. Yeah, oh, Ruud, when you finish this, please let me know.
Yeah.
Yeah. Okay. Alex, can you hear me? Cool. Yes. One moment. I'm going to add you. I still have an echo. Skype. Apply green screen.
Let the magic begin.
Chroma key.
Gee,
Wow.
I apologize for the crappy
So the
amateur
benchmark,
lighting.
just finished. And it's
No problem.
118 frames per second, so it's it lost 10 frames on average.
So
That's what Resizable bar can do for you. So don't expect like like 50%, but it can go up to like 10% max. Maybe in some situations even further, but don't expect it to be between unplayable and playable. But it will give you some nice extra.
yeah. So Ruud, let me without. So that's this one. Let me check if I can add that. Yeah. So I updated PPT. So we have the 10900K with resizable bar, 128 frames with, and 118 without. So quite a big gap.
Yeah.
So Alex also joined us. Ruud, if you put in your earbuds.
Yeah.
Then you can. So welcome, Alex. Good morning.
Good morning. Thank you very much. I just saw you guys were doing some testing with Resizable bar, and yeah, that's exactly with what I will be expecting, or at least what I've seen so far, or heard so far on expected gains between 10 to 16%, depending on the game title. One thing to keep in mind, right? This is a fairly new technology, so there's still a lot of improvements ahead of, right? So I keep my eyes open. It's just only going to get better.
Exactly.
Yeah. So. I see people already asking, nice beanie, Alex.
Thank you. The reason I have the beanie on is because I'm bald, so if I take it off, all this light is going to shine, and then my head is going to look like it's going to fading, like disappearing, and also it makes me look younger. So
then I need to do something here as well. I have the same problem.
I should wear 2 beanies then.
2 beanies, yeah. Hey, so Alex, you, for those who don't know you already joined us, I think last year, September, somewhere, October, when we were talking about the 10th generation gaming desktops.
Yes, sir.
Can you maybe explain a little bit what your role is within Intel?
Sure. My role is, the fancy title is Technical Evangelist, Community Manager.
Ooh. Cool.
No, what I actually do is I come and talk about our products that we launch and why they're cool and all the different features. And also, the idea is for me to talk one-to-one with the community, answer the questions, be completely transparent, tell them like, oh yeah, we did this because of Y, we did this because of X, give them like straight answers to the hard questions. Yeah. So that's my job. Just come here and talk to you guys and be as approachable and like, hey, there's a human being over here. That's me.
So Alex, if you see any question in the chat on YouTube, we can see all the platforms. You can either check YouTube or Twitch. I think the most questions will be asked there. We will try to pick them here as well. Sorry guys, if you have any questions, please drop them in the chat. And it's very difficult to answer everything because we also want to benchmark and talk about the new 11th core CPU, or 11th gen core CPUs, which launched yesterday. We're already waiting so long for that. I was explaining earlier. I mean,
it's the longest launch in history.
Yeah. We heard about it last year, like everybody excited, and then like beginning of January CES, we started streaming about 500 series. No benchmarks. You cannot tell anything about new CPU.
Here's a little piece of cheese. All
yeah,
right.
indeed.
Enjoy.
Indeed.
Here's another piece of cheese. Here you go.
That's normally how it works. Chong 1103 he is asking, why did MSI change the cooler design from an integrated radiator pump to the A-stack design? Please check our live stream. I think 2 weeks ago we had a live stream in depth with the guys from A-stack. They had the same title like you, Alex. They explained everything about what the benefits is of this design. And actually, both of the designs are still in the market because it's a different segment. Yeah. Sometimes I have to resize you. It's like a resizable bar.
It's okay.
Yeah, it's the Skype.
Keep it small.
Skype. So let's talk a little bit about 500 series chipsets, because that's that's the new platform, and that's how it started in the beginning of January, or let's say the 13th of January, I believe. A lot of new features on that.
Yes, plenty of new features. Actually, you guys probably know more about that than I do, but it's a lot of new features from going all the way from having USB. Wow, you gotta love the new way how they label those. USB 3.2, I'm just going to call it 20 gig.
That's
10
how
gig.
we do it.
Thank you. Thank you.
USB 20 gigs.
Exactly.
Thank you. Yeah, so all those is pretty impressive, plus also all the PCI lanes they have in there. And SATA, it's different things. There's a lot of new ports in there. And one of the things that we did making sure that the PCH doesn't become the bottleneck, right?
Yeah.
Because we have so many peripherals, so many features down there, is we have improve our DMI connection. So the DMI connection is the connection between
Which was
the CPU.
long overdue.
Yes, it is long overdue, actually.
Yeah.
Because as we said, now things are getting so much faster for the IOs, for the PCH, which was supposed to be like the slow part of the computer, but now it's so fast and so much bandwidth needed that, you're right, we were long overdue, but now we have it. So so pretty much we're trying to get rid of that quote unquote bottleneck, depending on what you were doing. So that was one of the great improvements there. The other things that we have as a platform is also the different things that you probably guys have on the different stack of your motherboards, is like the Wi-Fi 6 and the Wi-Fi 6E, the different Thunderbolt options, and so I'll let you guys.
I have some slide about that. So maybe let's talk a little bit about that, because it used to always be 1 gig, and now everything is moving to 2.5 gig. What about the adoption rate of routers and switches? Do you also see that coming up in the market? Because normally, I mean, it takes quite while. Expensive.
Yes, I agree. So so the 2.5 gig, if I recall correctly, the first time it came out, I think it was about a year ago, so it was barely new. And you're right, it was like, okay, I have 2.5 gig, but like, where's the router, where's the switch, how am I going to plug it in? But now, actually, since this has been a year, so there's been a bigger adoption. Actually, I was talking to a friend yesterday. He said that I was a little jealous that he already has his 2.5 gig network inside the house. I'm like, I want that.
Yeah.
I really want. Not only that, he also had his Wi-Fi 6, not E, but Wi-Fi 6 up and running. I'm like, what else do you want? I mean, you got everything on the bag of chips at home.
A lot of those high-end Wi-Fi AX,
routers.
So the Wi-Fi 6 routers, indeed, they come with a 2.5 gig uplink.
Exactly. So it's impressive, because now it's even faster than we used to have before. So that, and also it's not a Pokemon, the MuMaimo. I know it sounds like a Pokemon, but no, the MuMaimo capabilities, which is multi-user, multiple input, multiple output. Sorry, did I just state it myself? Anyways, but yes, it's impressive because you can actually have more devices attached to it, and it's able to communicate with them directly, not in a round robin fashion like it was before.
Yeah, removing all kinds of bottlenecks. That's the
exactly.
Key there.
Yeah, so that plus, I mean, there were a lot of smart routers before that you can actually dedicate the traffic of what you want to prioritize, but now it's even better with this new generation of Wi-Fi. And and you were saying also about the 2.5 gigahertz Ethernet, which is pretty cool. And the cool thing about that is, people might be asking, like, well, why not 5 gigahertz? Why not 10 gigabytes? 5 gigabytes. And the reason is because once you go that high, you need to pretty much redo the whole infrastructure.
The cables.
Exactly. Yeah. All the cables and everything. You need to redo that. But with 2.5, you can still stick to, is it
Cat 7, I think?
Cat 7, there we go.
Ruud, Cat 6 maybe.
6, yeah.
Cat 6.
Cat 5E is probably also fine.
Yeah, so you don't need to go buy, which are a little bit, well, I don't know, it's been a while since I bought cables, but as you go up in the Cat echelon, it gets a little bit more pricey. So that's why you have 2.5 gigahertz. You can still use everything that you have at home, all the infrastructure, and still get some great speeds. Yeah. So that's some pretty cool advances within the platform.
Yeah, but it's always like removing one bottleneck and finding the next one.
Yes, exactly.
Let's talk a little bit about the CPU, because that one launched yesterday, complete new lineup. I already see people asking why only 8 cores instead of 10. Can you let's maybe talk about this.
So let's go with that. Sure.
Maybe go to the next slide. Yeah.
So so why 10? Why 8 instead of 10? So there's a couple of things that we were looking into that. The first thing we wanted to do is we want to revamp the architecture, right? Because we had in the Skylake architecture for just a couple of years here and there.
By the way, Alex, I'm sorry. My apology, because in my email to you, I missed one of the pluses.
Yes, I pointed out. I was like, sorry.
Yeah.
I see you have 12 pluses instead of 13. This is the 13 plus that we had to. But you're talking about the technology. Yes. So So I'll go back to that one, but yeah. So we had the Skylake architecture that was being great for us for a long time. So we wanted to do something new, right? Something completely new, something new architecture. So we went and revamp it. And what we did is we went and grabbed the Ice Lake cores, which were named Sunico, if I recall correctly, and we ported them back. So that was a 10 nanometer process, and we ported back to the 14 nanometer process. The idea being that we will gain all those instructions per clock cycle. So we gain about 19% or so instruction per cycles gain on that. So we brought that in, thinking of the instructions per cycle gain. Now, the problem is when you backport some stuff, when you backport for 10 nanometer to 14 nanometer, you have to pretty much you run out of die space, because when you're designing, when you're doing the processor design or architecture design, everything is based around this transistor size.
Yes, indeed. Yeah.
So now you're going from 10 to 14, that gets bigger, everything gets bigger. So all the big blocks inside get bigger. And then you run into a problem of like, I have block A to block B, and there used to be some traces that go in there, but now everything's bigger. And so you have to move further apart. Now you have to retrace that, create all those routes again, and make sure that meets all the requirements. I'm not going to go too deep in that, but yeah.
But I was already discussing with Ruud. I mean, you also have the F SKUs without the iGPU.
Exactly.
Wasn't it possible to include 2 or 4 extra cores in those kind of CPUs if you don't have the integrated graphics?
Right. So what happens is sometimes, so we do a lot of quality check. Well, since quality check for us begins even from the design when we're designing our processors. So one of the things is if we see that a processor doesn't meet those quality checks, for example, if for the graphics doesn't meet the quality checks, we take that out. So we just completely turn it off.
Yeah.
So creating, so there's 2 things. So we do that, and the other thing is if we wanted to create a completely a die without graphics, it will be a completely different architecture, a completely different die, right? Because you have to redesign everything, because now you have these empty spaces, or like you said, you have to add 2 more cores. So that's a completely, almost like a new design, because you have to make
and those designs, they take a long time.
They take a long time, and they have to, so long time validation. So there's a bunch of other stuff that comes into place. So
I think that's a clear answer to why are there only 8 cores.
So sorry. Long story long. The 8 cores is we ported back from 14 nanometers. They get bigger. We only had room for 8, but we're counting 2 things, right? The instructions per clock, so 19%, and the reason we added 1 more plus to the 14 nanometer is because with the frequency, right? So we wanted to do it in 14 nanometers because we already know this process really well, as you can see by the number of pluses that we have. So we can hit those high frequencies that we're looking for. So we'll have the 19% IPC plus the plus the high frequencies. I was going somewhere with that. Yes, we'll have a great scaling of all applications, because what we have seen is all applications scale with frequency, right?
Absolutely,
and not all applications scale with core. And that's not saying that you don't need cores, but just saying that, if we really want to make an impact on performance, frequency is one way to be always on point of always getting performance.
True. Yeah. Okay. Clear. I think we have here a lot of features. Most of them we're going to benchmark, Ruud, because I want to get. Oh, Ruud, maybe. Do you still need to run some benchmarks on storage on the 10 gen?
Yeah, we do. Yeah.
Yeah. Maybe I will go to. Let me see, Alex, if you're also included in this one. Yeah.
So basically what I have here is the C drive is just a SATA drive. It's where Windows is. And then I have the D drive, which is basically 2 Western Digital.
Make this bigger? No.
Oh, should I move it?
Yeah, please.
Okay.
Yeah, so everybody can see.
The D drive here, that's a RAID 0 stripe set of 2 Western Digital black SN850. So very fast SSDs. These are PCI Express Gen 4x4. But since they're attached to the PCH, they're running in Gen 3 mode. So a single Gen 3 SSD of this this model will top out around 450 megabytes per second in Crystal Disk Mark. And if you put them in RAID, you would expect it to be close to double, right? But this will not happen because the DMI of this Comet Lake, the 10900K, only has like a Gen 3 by 4. So when we run it, it will show you something like the same as a single drive, like a 3450 or something. Let's
so I can, let's talk maybe Ruud about the DMI.
Yeah.
A moment, let me get this slide up.
Already showing the first number, so it's 3550. So that's close to maximum of the Gen 3 by 4, which is with the 10900K. That's the speed. The PCH is attached to the CPU. So that's basically the bottleneck at this moment.
Yeah, so in a diagram, on the left side you see the 400 series with the 10 gen CPU. The architecture allows it to connect two M.2 Gen 3 X4, which basically run in each in 4 gigabytes. Gigabytes, right, Ruud?
Gigabytes, yes.
Yeah, Ruud said, don't use bits, use bytes.
Everything bytes. People store stuff in bytes.
Yeah, okay.
Bits.
So, and then this of course needs to go via the PCH, via the chipset, the 400, so Z490 or B460, sorry, to the 10 gen CPU. And that's where the bottleneck is. That's where you have the DMI. The DMI is the, I think, direct media interface. No?
Yes, sir.
Yeah? Okay.
That is correct.
Good.
Very good.
Which is basically the communication bus between the 10 gen, let's say the CPU and the PCH. So what Intel did in the Z590 platform, because this is only in Z590 in combination with 11 gen, correct?
Yeah. Correct.
Yeah, so then the DMI bus got doubled by Gen 3 Gen 3 X8, so doubled from X4 to X8. So if you're going to look this X8, you can easily run, well not easy, but it fits in. You can run two M.2's Gen 3 X4, which are each 4 equals 8. So then you don't have any bottlenecks anymore. And additionally, Intel also added 4 extra PCI Express lanes for an extra M.2 connected directly to the CPU. Yeah. And this one on the 11 Gen, of course, it runs generation 4, PCI Express Gen 4.
Yeah.
So back to your benchmark, Ruud.
Yeah, it's finished. So this is the score you will. Oh, it's not updating, Eric. Why?
Oh, maybe.
Because it's a demo live. That's
yeah,
why.
It's a live demo.
Yes, there we are.
There we are. Yeah. I mean, on my screen it was already finished, but I wasn't seeing that in the OBS one. So yeah, roughly you can say it's about 3,500 megabytes per second or 3.5 gigabytes per second, which is the practical maximum of a Gen 3 by 4 PCI Express bus. So even though it's 2 SSDs that can run faster, we can show that when the DMI by 8 is run with the 11900K.
So I should write down 3.5.
3.5?
Yep.
Yes, that's what we do. I can also run the memory benchmark if you want.
Yeah, sure.
You can continue with the story.
Yeah.
We'll use
So Alex, let's talk a little bit, because Ruud is going to do some memory benchmarks. Let's talk a little bit about the SKUs, the CPU SKUs.
Sure. So, okay, so for Rocket Lake, the CPU SKUs that we have the whole stack from Core i5 all the way to Core i9. Of course, that will be including our Core i9K, Core i9KF. The KF, the F means that the graphics part has been disabled.
Yeah, indeed.
Yep, and the same thing goes for the i7 and the i5,
so
right?
It's disabled, but still it's there.
Yeah.
And
correct.
I mean, why not why is disabled? Are they cheaper?
They're disabled because as you do a lot of, not all, like we were talking before about the what do you call it? The quality.
Yeah.
So we have high standards of quality. If we see that it doesn't meet our standards, then we rather turn it off, right? Because the last thing you want to do is like, oh, this chip is awesome, and the first year the integrated graphics is great, and then the next year is like, wait, where'd it go?
Yeah, indeed.
So we want to make sure that the integrated graphics lasts for the whole for the whole usage of it, right? So we go through rigorous tests. Back in the days when I was an engineer, that was one of the things that we had to do a lot of testing. Make sure that it was going to live for at least. Actually, I don't know if I can tell you, but it's a long time.
Yeah, indeed. So, and because, I mean, just I'm just brainstorming. This means that the iGPU doesn't take. I mean, it takes up space, but it doesn't take up any power, and it doesn't take any. It creates any heat because it's disabled.
And that's why a lot of overclockers really, really like those parts.
Yeah,
including myself.
I didn't know, but I mean, I was wondering, indeed.
Because So they actually, if you the overclockers really like to look for it because that is a lot of a power draw, power consumption. So they'll give them more power overhead, temperature overhead to crank those frequencies up.
Okay, and I think for a lot of gamers, if you really talk, I mean, the gamers, they always want this discrete graphics.
I mean, exactly. Boom.
Indeed.
That's also a great like. I mean, we all don't have money to throw away, right? So one of the great SKUs that we have there is the i5KF.
Yes.
That is a really, really, really good SKU. So that will be the 1600 KF. If I recall, sorry, that will be probably the next slide. But
next page.
Yeah. So it's okay. Yeah, so I would definitely highly recommend that one. That one's really cool. I really like that one. The price performance, it's amazing.
Sweet spot, yes.
Exactly, that is the sweet spot.
Yeah.
Yeah.
I think most people know K is unlocked, F is without graphics. We also have T. T is not for the normal consumer. That's more for system integrators.
T is a lower. T means low power consumption. I think T is 35 watts, if I recall correctly.
Yes.
Yeah, because we also had another one back in the days which was an S. Yeah.
Mm-hmm.
If you're editing, should I go for iGPU? Like programs use it. Question on Twitch. Can he? I mean, depends on what he's editing. If you're editing source code, you can.
Yeah, exactly. So let me give you a little background of. A lot of people ask us like, why do we have iGPUs in there, integrated graphics? Mm-hmm. The reason is when we designed this processor, we have to design it for everybody. And there is a lot of demand in the commercial side and the business side that demand as in they don't use discrete graphic cards. Yeah. For us, that's like, you don't use what? Yeah. Excuse me? How dare you? But on that side of the world, they don't use discrete graphic cards. So for them, having integrated graphics is a really big thing. And as they get better, it's great for them too. So that's one of the reasons we actually that's the big reason that we included there. There's a lot of demand for it outside of gaming. But back to the main question, what will you use it for? Yes, you can still use it for gaming. Obviously, it's not going to be high. You can use it at high rates, but you can still have some decent games play there pretty well. We have improved from last generation. I think when I saw the numbers, it was about 50%. So
how do you pronounce the name? Because this is the iGPU, which also was in Tiger Lake. But it has a fancy name, X, and then I'm lost.
You know us and names, right? So.
Model numbers, yeah.
I'm not sure if I have the name somewhere written down.
The Iris
it's Intel Graphics UHD 750.
No, there is another name.
Well, hold on. It's Intel UHD Graphics 750 using the XE graphics architecture.
Is it just
it
XE?
Rolls off the tongue.
Yeah.
It is. Yeah,
Easy.
it is. Yeah, exactly.
XE.
Yes, it uses the XE architecture, right? So it's not as. So this is from Tiger Lake, right?
Yes,
from Tiger Lake
it's from Tiger Lake indeed.
So Tiger Lake used what we call 96 execution units, EUs. So what you will call in the other video cards nodes or CUDA cores, or I forgot the other one.
Yeah.
But yeah. So we have 96 units on Tiger Lake, but here on the desktop we have a 32. That's right. It's not as powerful.
32. It differs per CPU.
Yeah, exactly, per CPU.
Yeah.
So 32. It's not as powerful, but even still, with only 32, we're 50% better than we were in the 10th generation. So that just tells you how much that architecture has improved or has made huge advances on
And
performance.
this basically is the same architecture you're later planning to use. I'm not asking you to confirm stuff for discrete graphics cards. Oh, okay. Okay, so
I cannot confirm or deny that,
yes.
but you know, if you just go to the right places on the internet, I find stuff.
So so that's i5, i7, i9, and i3 and Pentium and Celeron. No, I don't see Celeron.
Yes.
Is Celeron? No Celeron.
Yeah. So Celeron. I don't know.
No,
Yeah.
it's no Celeron here on my, not on my page. No.
Yeah. So Pentium and i3, those are going to be refresh.
Just a speed bump. Basically.
Exactly. Speed bump from the previous generation. Yeah. So that would be a speed bump.
If we talk about speed bump, it's like first was, let me check some speeds. First was 2.9, now it's 3. Or 2.8,
Yep,
now
exactly.
it's 3. Something like that.
So it's the speed bump is what we call within Intel 1 bin, or which is 100 megahertz.
Yeah.
So yeah, that will be the bump for the refresh.
Same price, more performance. Simple.
Yep. Same pluses.
Okay, Ruud, you were doing some benchmarks.
Oh yeah, one has finished. So now the memory benchmark is here for the 10900K. I'll make a screenshot, but you can also write down. The interesting part here is the copy score. Shall I drop it a little bit?
1
You
moment.
were zooming.
Yeah.
So that's like 47.3 gigabytes per second.
So 47?
So 4.3 gigabytes.
4.7374.
Okay.
Yeah.
Nice.
And this with a DDR4 3600 G-Skill memory.
So it's 47.4 latency.
Yeah, and latency is 47.4 nanoseconds. Yes.
So
some games respond more to memory bandwidth, and
Should be
some
fine.
respond better to lower
latency.
latencies.
Yeah.
So yeah.
Yeah.
We'll
Ruud,
show you more about that with the Gear 1, Gear 2 on the
Exactly.
on the Rocket League one.
Ruud, you maybe while we're talking, maybe you just run some Cinebench.
Yeah, sure.
Maybe pick one of them. Maybe only 20.
So Wood was actually honing into a very interesting message, which is the new implementation of Gear 2, which it pretty much is, what it's doing is doing some timings inside the memory, so you can get like you're still running, let's say, a 3200, but using half the frequency inside the memory controller, and that will crank up the frequency. But even though I haven't seen it, it will see a little hit on latency, but we'll figure it out once Ruud runs the benchmark. And like he was saying, there's some games that respond better to frequency, and there's other games that latency is something to look out. So now you have the two options, you can either with the Gear 2 or Gear 1 half, depending how it's labeled. You can definitely crank up the frequencies a lot.
Later,
higher.
we're also going to do benchmarks.
Oh, sorry. I was jumping the gun.
No problem. We have too many topics to talk about.
Yeah. Exactly.
So Ruud now is running Cinebench R20 on the 10900K, just to have some reference scores. So Ruud, I will skip 15, right? Or you want still 15 single?
15 is interesting because we can run the single-threaded benchmark, which doesn't take as long as the Cinebench 21.
Did you measure power for the?
Yeah, I did. For the 10900K, it's running unlimited, so there's no power limits, there's no current limits, there's nothing.
Let me zoom.
Just our bias lets it run free as long as your cooling is in order.
Can you get it in the zoom?
Zoom. Then I'll move this one here. This is the power, so that's about, like, say, 220 watts.
That's okay.
Yeah. And for example, the cores, it's an all-core workload, so it's running 4.9 gigahertz on all 10 cores.
Nice.
So that's a lot of power, but it's also a lot of performance. So the performance being 6,227.
And what is the score?
That is the score.
Oh, sorry. Can you?
6,000. Can you
two-
write down 6,227?
Perfect.
6227.
I did it.
Okay, cool. I will run the Cinebench 15 single thread, and you can continue.
Yeah, so let's, because Ruud was already talking about, well, anyway, Ruud is behind on schedule.
Yeah,
Why,
who's to
Ruud?
blame?
Just blame me.
Okay.
Shall we
continue.
blame Alex? He talks too
Yep.
much.
Well,
No, we were already behind, Alex. I'm just joking. I'm just joking.
we all talk too much. The thing is, we're so passionate about this that we can spend the whole day talking about it.
Yeah,
So,
indeed. And there are too many topics to talk about. I mean,
yes, there's a lot to cover.
maybe next week again, Ruud.
Yeah,
Sure.
or just continue till 8 o'clock this time.
No. Security always kicks us out at,
at
7,
yeah,
so that's like in 1/2 hour. I mean, anyway. So let's. I mean, we talked about the SKUs. I wrote down the scores, as you can see here. Almost. You also need to watch Dogs, Ruud, if you want.
Oh yeah,
So,
Watch Dogs, yeah.
Let's talk a little bit about Rocket Lake S. That's actually the code name for the 11th gen CPU. About package power, this is huge, and this is with how do you call it? AVX. So
Yes.
and then that always gives a huge load. Ruud, can you maybe tell a little bit about this?
Yeah, when running Prime 95 with all the AVX, the new Rocket Lake even does AVX 512. That puts a lot of power into it, but also a lot of current. And the current is also driving up the heat in parts of the CPU, so it will respond with the temperatures a lot faster than if you have a normal workload without AVX. So the temperatures will shoot up like immediately. So the cooling will be very important, or you need to limit your power. You can do that in the BIOS. So you need to fine-tune your cooling and your power limits for your system. So don't let it run unlimited unless you have decent power and decent cooling in your system.
Yeah, so to give a little bit of insight on the AVX, so AVX is an instruction set, and usually the instruction sets that you see on an x86 architecture, right now the majority of them are on 64 bits, right? So what happens with AVX, well, you have AVX and AVX 512, and as their names say it, is you are increasing the size of the instruction. So that also means you're increasing the bus bandwidth. If I'm getting too technical, let me know. You're also increasing the bus bandwidth, and in order to do that, you are activating more transistors. So you're turning on more stuff. So that's why you have more energy and more power consumption. Like your instructions will go in faster because you have a bandwidth, but at the same time, you're turning on more transistors. So with AVX, I think you're turning twice the amount as if you had just the regular instructions, and with 512, it's like 4 times the amount of transistors.
Yeah, I think maybe the advantage of this is that nobody uses this. I mean, if we talk about gamers.
Yeah, exactly. Yeah. So on the gaming side, you can. Yeah, I don't think I've seen a game that implements that.
So I mean,
probably
you see a lot of reviews about those horror scenarios where like, we're doing 300, 400 watts, and I mean, what you see here on the screen.
That's a power virus, basically.
This is a power virus.
Who is that interested in prime numbers? Anyway?
We're lucky it's not spreading.
I mean, who is gonna spend like 400 watts on an 11900K just to find new prime numbers, right?
Yeah,
it's just run as a stress test, not as an application to do something, right? It's not a game. It's not. It will not produce any video or whatever. So if you see the real applications using AVX, for example, Blender, that has nothing near that kind of power draw. No. So the real applications that use AVX don't have the power draw that the power viruses have, like anything based on LinPack. That means AIDA stability test, OCCT, Intel burn test, and there are some names on it, and Prime 95 being the most popular one of all. So those are just to heat up stuff. It's not to
to barbecue.
You're not even testing how fast it goes, right? No. So you don't even have performance numbers to show, and it's just heating up stuff, and
Yeah, so a lot of people, they are scared by those numbers, but it's not realistic at all. It's not something, especially not what gamers are using. Yeah. And if you're using Blender, you are very happy that you're using this because it's going faster, and the power draw, like what Ruud said, is not as near to those numbers I just showed you.
No. I also don't know the amount of mix of regular instructions and AVX instructions the blender has, because if you do like full AVX like Prime 95, it will heat up stuff. And so what we were missing basically is an AVX or AVX2 or AVX 512 benchmark that will show, okay, you can do this kind of application much faster. But at the moment, there's not really a benchmark. That
I'm fitting you in here as well. Perfect.
Okay. The Cinebench one is also finished, so if you want to...
Okay, one moment. I want to do a giveaway.
Oh yeah, giveaway.
I mean, that's why we're here. I know. Next to winners, Jones Wong and Connor. Congratulations, Connor, with a loyalty bonus. Thank you very much for that. In the coming days, we will send you the game code. If you want to participate, go to msi.com/2/insider, or on YouTube and Twitch. We have a bot running each 5 minutes. It also spams the Gleam link. Let's continue. So, Ruud, you had...
Yeah, so the score being 220.
Yes, almost.
Oh, almost, yeah. So 220. Yeah, there's some delay on it, so I shouldn't
move
it
it
as quickly as I normally would. 220 Cinebench, 15 single thread.
Then we're just missing one, which is
Watch Dogs, right?
Watch Dogs. Yeah, if you want, if you have time. I'm not sure how long it takes.
I'll just run it and you can continue.
Sure. Let me.
Okay, let's continue with this one as well.
So, Ruud, can you maybe tell a little bit about this? This is basically how the package power and the voltages behave, right?
Yeah, and this is the overclocking part that our headquarters did.
Yes, this is by our overclocking team. We have an internal overclocking team led by Top PC. Maybe you... actually, the memory record he also made. And he's... if you... No, he was not in the HU video. When we visited HU in December last year, not last year, 2019, he didn't want to. no camera, please. Anyway, he's our internal overclocker, and he's always testing this kind of stuff.
But he's on YouTube now.
But in Mandarin, in Chinese.
Yeah, of course, yeah.
Sometimes with subtitles. But this is indeed internally with overclocking how much the package power scales with the CPU vCore.
Yeah, so the vCore, if you want to do like 5.1 gigahertz on all 8 cores, then it will, it can draw up to 325 watts with 1.37 volts. That's probably what's minimum required to run 5.1. So biases can differ, CPU chips can differ, so it's also a little bit of a silicon lottery there. Some chips need more voltage, so it will also output more power. Or require more power, I should say. If you want to do 5.2, then the power consumption goes even further, and then water cooling will not be enough anymore. So you will probably need different methods of cooling, like liquid nitrogen or a chiller or whatever. So that's basically what they are testing there. So
then we have this one as well with the temperatures.
Yeah, the temperatures depends, of course, on what kind of cooling you're using. They say it's a DIY water cooling kit, so it doesn't really say which one or how much radiators or fan speeds. So hard to say, but it does show that the temperatures go up quickly. And with a do-it-yourself water cooling kit, it means a custom water loop.
But this is all again for
CPUs.
For overclocking.
Yeah, so for overclocking, temperatures will be your enemy, and power consumption will make those CPU temperatures go up quickly.
Yeah. A few questions from the chat. Do gamers need AVX 512? Alex, maybe you can comment on that?
Sure, yeah. So as of now, I don't think they needed 512. I haven't seen any games actually implemented. So the most, I think you don't need it 512 for that.
Same person with a Korean name, so I cannot pronounce his name. Should we wait for September? I'm not sure what September brings. But
September is a lovely month. It's great. It's it's the change of the season.
True.
I know what he's asking, but unfortunately I cannot talk about future products. Should we wait about September? I don't know. Actually, I don't know. I was looking at.
If he's asking about a future platform, it's quite simple,
Yeah.
you know. Everything what comes in the future is better. And
Yeah, exactly.
yeah, so you can keep upgrading because in so September, I'm not sure if there will be and launched anything in September, but 2022, 2023. I mean, new platforms will come on the market, new technologies will emerge. It will always be like that. Question: all reviews show that the 10th and the 11th gen performance difference is minimal. So why should I go to the next gen? Basically, that's the question.
Right. So I can see why if you just have a 10th gen, how you think about not going to the 11th gen. But one of the things that we do is not a lot of us or not a lot of people are refreshing their computers year over year,
Yeah.
right? So what we have found out is people, well, actually gamers refresh their hardware a lot faster than the regular folks. And the refresh cadence for the system is about 3 years. So 3 years is actually a long time if you think about it. So 3 years ago, 3 years and a half ago, we didn't have PCIe Gen 4 in, I don't think in any of the platforms. No. Exactly. So now PCIe Gen 4 is a different thing. Also, you have extra lanes connected to the CPU, and those will help with storage. I think 3 to 4 years ago, just PCIe Gen 4 on SSDs were just starting to come out.
Yeah. I think it's
I don't even think so.
indeed something as an upgrade platform. I mean, nobody from 10 gen will go to 11 gen because it means that that they're upgrading like each year.
Exactly.
But if you look at like if you have a 2 or 3 year, maybe 3 to 4 years even old platform, I mean, I think you maybe have USB 10. Maybe not.
Yeah,
But Type C,
but the
USB
most
10. I mean, it's not only the CPU,
yeah,
it's the whole platform.
USB-C, yeah. Not only that, but the most important thing in there was like, was there RGB 4 years ago?
Yes. Yes, yes, for
Definitely need
sure.
RGB.
RGB equals frames per second FPS,
yeah,
man.
put it on red, it will give you a few extra.
Yeah.
Exactly, especially if it's in rainbow mode.
Oh,
So,
rainbow is
there you
even
go.
better.
Ruud, you have your benchmark ready?
Well, yeah, we ran Watch Dogs Legion, 1080p and high settings, so it will give you an average FPS of 133. So you can write that down, and we can see if we can top that with 11900K later on. Is there another benchmark I should run on this system?
No, I better say no, because I know if you and benchmarks, you benchmark the whole day.
Of course, but what I mean to say is then I will shut it down and we'll put the new CPU in.
Yeah.
Yep.
So these are all the scores with the 10900, so last generation. And I mean, sorry, Alex, maybe it's not fair for me to compare this directly with last generation because
No, it's okay. Well, don't worry.
like
I
what
mean,
we said,
everybody's doing it.
we're not. I mean, this CPU is not for people with a 10900K to upgrade. This is from like me. What I have at home? Did I say six?
Exactly.
Six generation. Six
No, but it's fine.
700
As a reviewer and as a technology enthusiast, I will expect you to do that. So that's fine, then. Don't need to apologize.
So. So Ruud now is going to change the CPU in the system.
Yep.
Ruud, maybe you can show the box.
Oh yeah, the box, right. Don't know if this is the retail packing or not, or media one. Okay.
I have a picture of that.
It, right?
Yeah.
Yeah, I saw.
I'm sure that they don't allow me to keep this. I'm sure they will ask, hey, Eric, so you did your live stream, can you send it back?
Cube.
That's cool.
With a green screen thing going on. But the CPU is inside this one. So let's open that up. Of course, I already opened it up and it's already full of thermal grease.
So you just put it back in, like,
oh, this is really
let's do an
cool.
unboxing.
No, it isn't. The thermal grease didn't come from Intel, it was mine. So anyway, it just looks like a regular CPU. We'll just put
not like a rocket?
No, not like a rocket. No.
Okay.
There's no rocket anywhere here, is it?
No.
No. On the box? And a cube. It just says Intel on mine, or maybe we got the the rocket is on the.
Oh, cool!
Here the rocket, yeah. Ah.
Oh, cool.
That's why you're the evangelist, right? Exactly. Yeah.
So I see people reacting in the chat like, oh, that's a big box for a CPU, lol.
Yeah.
So this is not a retail packing. This is like a package which is sent to customers and to media. And somehow, by accident, I will go to the normal view. Sorry, Alex. So somehow by accident we got this here. I don't know why. But this is how the normal packing looks like.
Okay.
I believe, right, Alex, for the i9.
Oh, looks nice.
Sorry, there's a little delay, but yeah, it's like the.
It's like
the jig.
Indeed, that box.
That will be exactly.
I was actually disappointed to get this big box. Sounds crazy, right?
There's no way we can make everybody happy. True. People are disappointed, like, I didn't get the big box, and then the people who got the big box, like, I can't get this small box.
True.
And yeah, for the chat, don't worry, guys. Ask the questions, and the hard questions is fine. I understand. So I think that was Troy that he was just saying that he has to ask the hard questions. I'm like, yeah, it's okay. That's what I wouldn't expect anything less.
And he knows, he's a regular viewer. He knows that we also try to answer all the questions. And I mean, sometimes the answer is not satisfying, but that's just reality.
Yep, exactly.
I know.
Now for the awkward silence.
You only get banned in our chat if you use capitals, but we blocked that, so. Ruud, can you maybe, I know you're busy, but can you maybe check the Unify board?
The ITX one or the
No, the ATX one. We have a question if the Z590 Unify X has an HDMI port. We don't have the X one, but I assume, let me go to details view, yes.
That one, yeah.
I believe all MSI
it does have HDMI.
Yeah, I believe all MSI motherboards in the 500 series have an HDMI port, except for Godlike. Godlike, we put all the faces for the VRM on the CPU. So no VGA output.
Do you still need it or not?
No.
Oh, okay,
you continue doing your stuff.
Swapping CPUs, yeah. Okay.
So let's maybe. So AVX, we already talked about it. In this generation, it's also possible to disable it. So either AVX or AVX 512. And there is also some guard, band, scale, volume. Like,
it's easy to pronounce.
Yeah, but it's like for overclockers, right? I don't have to care about this.
Yes, it is. Yeah, so actually I think there's a part of the new knobs for overclocking. There's like AVX on off, there's an AVX offset, which is probably the guard band. And the AVX offset is what it is when you are starting to overclock and it all of a sudden, when you start overclock, let's say you overclock your system, and then there's an application that uses AVX. What the processor does is it recognizes it as an AVX and it downshifts the frequency from, let's say you set it to, I want it to always be at 5.1, 5.2, but as soon as it hits that AVX instruction set or application, you tell it to, okay, I want it to have a guard band of 2 megahertz, so bring it down to 5.2 or whatever you want. That way you stay stable and your power consumption and your heat stays there. And once you're out of that and go back to gaming or whatever other application you're using that doesn't have AVX, then it will go crank up all back to 5.2.
Okay, that's more or less in the past. A lot of those specialized overclockers, they had of overclocking boards. They had a button on the board.
Exactly.
You get, for example, 3D Mark. You had something was like GPU heavy, but you didn't have to use your CPU, so you turn back the CPU ratio. Okay, clear. Ruud is still updating his platform, his benchmark platform to the 11900K. I'm going to show you some benchmarks we did with the Z590 Godlike, running 11900K CPU at 5.2 gigahertz, 1.4 volt. The VRM temperature here is important because We talked earlier about that. We did a lot of improvements on VRM. And with this, we're talking about temperature of 61.5. So that's pretty cool.
That's also with AVX. That's the AIDA 64 stability test, which is one of the power virus thing.
Yeah, indeed. So this is a full load on the 11900K.
I would say it's an extreme load. But
indeed. So that means the VRM stays very cool. Same with ACE, with the same benchmarks, also 5.2 gigahertz, 1.4, and then it's 65.5. So let's go back. So it's like 4 degrees higher. But this one also has a different VRM on the ACE because, like what I said, Godlike has direct VRM. And ACE, we're talking about the mirrored VRM, which we talked earlier in this live stream about. The VRM improvements are also on the gaming carbon. This is what Ruud currently is updating his CPU, upgrading the CPU. And for this one, if we run 5.2 gigahertz, 1.4 volts, you can expect VRM temp about 76.5 degrees. And then I have another example. This is one of the entry-level ATX boards, Z590 Pro Wi-Fi. So it's just a basic board, also 5.2, 1.4 volt, and then you're talking about 91 degrees. And I mean, like what we said, it's a power virus, so it's not a typical workload you're running. So you don't. This is during normal gaming or normal office use. You don't run into these extreme scenarios. But this is just a stress test by our OC lab to show you what the temperatures are, what you can expect. And this is a big improvement. I mean, 91 degrees, no problem at all. So, Ruud, let me check. Yeah, ABT. Maybe that's the first topic you want to talk about?
Well, let's do the testing first with the default. See how it behaves.
Okay.
Ruud
is making a nuclear weapon.
The first question you will get asked when you swap a CPU in our motherboards is what kind of cooler are you running? Eric also has a slide about that.
Oh, I need to...
Yeah, you can look it up later.
Yeah.
But
No,
I'm just
this
going to
is
select
the part.
water cooler as that will... Yeah, that's exactly the one. If you choose water cooler, then all limits are turned off. Means we expect you to be an expert if you are building a system with a water cooling in it. You probably know about performance and power and cooling, and you should be able to tune it yourself. Most of the times, if you have a very large water cooler, then running the default should be fine. The only thing I'm going to enable is XMP, so that will run the memory at the rated frequency. And then just press F10 and exit. Save and exit.
Yeah, so basically it means if you're running your CPU, if you start your mainboard for the first time, you get this wizard. You can select the CPU and the power limits which are attached to that.
You can always change it later in the overclocking menu or in the easy menu. You can just pop up cooling selection, and then this will pop up again.
Yeah. And Ruud, if you duck a little bit, you can always manually edit the CPU current limit.
My chair is in the way.
Yeah, it's perfect.
That's the current limit one. There's also a power limit, like the long duration a power limit and a short duration a power limit. Those are interesting if you want to play around and see how far your coolant can get. Also when overclocking and you want to limit the power of AVX loads and stuff, you can also use the power limits instead of just using the AVX offsets. This will help a lot. You can always also go to the current limit, and in this screenshot it says 245, which is the official spec of Intel.
Yeah,
245. That's also what's called ICC Max, and if you adhere to this limit, then it's not considered overclocking.
Correct.
You can still do power limits, unlimited, depending on your cooling solution. Also, I'm getting a blue screen. That's also a new one.
Reboot.
That's great.
No, it's called the demo
The
gods
demo
are talking
gods,
to
yeah,
us.
yeah. I think Bill Gates had the
Can
same
I
problem.
capture your blue screen? No, it still
Yeah.
shows the Alt and the I. So maybe because Ruud first wants to run his standard benchmarks to have a
Hang on.
baseline, and then talk about ABT. But maybe I can already, let me see, talk with Alex about adaptive boost technology.
Technology.
Yeah,
Yes,
so
sir.
basically it comes down, you have a lot of different boost technologies. I mean,
Yeah, too many now.
What are you talking about? I don't know. I don't know what you're talking about. We don't have enough boosts.
Thermal
There's
velocity
always.
boost and adaptive boost.
Did
What
you
else?
did, did
Turbo
you bring the
boost.
decoder ring?
It's amazing. So can you maybe explain
Yeah.
a little bit how this slides works? Because we're talking about the 8-core
Yeah, it's-
CPU, and this technology, of course, differs per CPU. If you only 6 cores, the values per core will, of course, differ.
Yeah.
More entry-level CPU, the values will also differ in clock speeds. But so this
Exactly.
example, oh, it's actually, yeah, okay. So this slide is for adaptive boost technology, something new.
Well, it's adaptive boost, but it also helps to explain all the
Yeah.
other turbo boost, but only for the 9K. But you can use this as a map. So let's look at it from this way, right? So first of all, we have turbo boost. Well, then it became turbo boost 2.0. And what turbo boost means for those who are new to the computer world, it means that usually your processor comes in at a certain frequency, and then with a turbo boost, you can actually go over that frequency. So let's say, by example, if your processor comes in at 3 gigahertz, then the turbo boost will take it to 3.2 gigahertz for a period of time.
Yeah.
And the period of time that you stay at turbo boost is either dictated by the power consumption, the thermals. So most of those two are dictated by how long you're going to be able to stay there. Or we have also set some specific timings within the BIOS, which is called tau. You probably will see it there on the motherboard BIOS.
Yeah.
Now, so keep staying to the story. So as you can see here, you have cores 1 through 8. So let's take for now to Turbo Boost 2.0. So when you have when your application is only using 2 cores, your Turbo Boost will take you all the way to 5.1 gigahertz. And as you can see, as you increase cores, so if you use 4 cores, now all your Turbo Boosts are just going to hit 5 gigahertz. 5 cores, you're going to hit 4.8. Yes, 4.8. And then if you get all 8 cores, you get 4.7.
Yeah, but that's only for the
So that is-
last 2 cores, right? So the first 2 are
Exactly.
running at 5.1, and the last 2 are only running at 4.7. Or 4.7, yes.
Yep. So that's Turbo Boost 2.0.
Okay.
And because we like Turbo Boost so much, we created Turbo Boost 3.0, because you can always turbo more. Sorry in the background, that's my laptop fan going crazy.
That happens.
Yeah. Okay, so we got. Sorry, but you're going to say something, Aaron?
No, I was pointing to the 3.0 version, Turbo Boost 3.0.
Yeah, there we go. So Turbo Boost 3.0, what it is it selects each processor out of the factory. We do a test to figure out which one is the best core for overclocking or for higher frequencies, and those get labeled. And those 2 cores will be able to hit higher frequencies. So Turbo Boost 3.0 is we'll pick the best 2 cores, and then we'll crank them up all the way, for example, for this processor to 5.2.
Yeah.
Awesome.
Free performance.
All right, so yeah, exactly. Free performance out of the box. Now, after that, we have this staying in theme of boost, because like boosting stuff. We're doing the thermal velocity boost. They're all rolled pretty easily.
So
off
basically
the
this is
tongue.
4.0.
Yeah, exactly. Yes,
Okay.
yeah, exactly. So for those who are keeping track and enumerating, this is Turbo Boost 4.0. Which, you'll think that we call it Turbo Boost 4.0, but,
Fancy name.
Yeah, so exactly. So this one, what it is it will actually take you all the way to 5.3, the core 1 and core 2. We'll try to do that. It will take into account also thermals. The only difference is the thermal headroom for this guy is at 70C. So, for example, if your processor is under 70C, it will go all the way out and try to hit that 5.3.
Yeah.
If it's over 70C, it won't be activated.
Yeah.
So
Basically, that is
would
what
be
we're already telling in I think the last half year, maybe last year, during our live streams. Cooling matters.
exactly. Cooling matters a lot.
Yeah. The better your cooling, the more heat you can remove from your CPU, the higher and the longer you have, you will run in boosted frequencies.
Exactly. So after that, for those who are keeping track, we have adaptive boost technology. So that will be called that, between us friends, we call that Turbo Boost 5.0.
Yeah, cool. So this is the stuff ABT. I should use my cursor here. ABT over here, and ABT over here.
Exactly.
So basically, it looks to me like an all-core boost.
Exactly. It's an all-core boost that will send you to 5.1 gigahertz. So it's an all-core boost that it will hit you to the frequencies that Turbo Boost 2.0 will hit you, will get you for only 2 cores. Yeah. So that is pretty neat. Like, you're getting 5.1 gigahertz out of the box for all cores.
People are asking if they can go to bed. No.
If they can go to what?
If they can go to bed. Probably Asia, probably already very late.
They can go.
Good?
It depends on their parents.
Yeah. Good?
Yeah.
Working?
Yeah, it should be working. I made a stupid mistake. There are only stupid mistakes, of course.
Did you put the memory upside down in?
No. I thought it was the cooling. But
Get a hammer. Get a hammer.
Yeah. The reason it failed is that there are 3 SSDs inside. 2 of them are in RAID. We saw that with the...
you forgot to make the RAID setup.
And the third one is in the first slot that can only be seen when there's a 11 gen CPU inside. But since the BIOS reset, because I changed the CPU, it's trying to boot from that one. And there's also Windows on that one I didn't remove. So
an old setup for a different OS?
Windows. So it could be an AMD installation or whatever. But it's not booting on this system. So
did you enable NDI already?
Yeah, should be. It's starting automatically. So just capture mouse cursor.
NDI stuff, we really need to spend some time on replacing this.
Yeah, we should have a good capture card, an extra one. Yeah.
Yeah, I already asked some friends.
Not sure if you can see the desktop. Now I forgot to enable XMP, I think.
So you reboot first.
Yeah. Okay.
Otherwise, it's like cheating. I'm just going to do another giveaway.
Ooh, what are you guys giving away?
Today we're going to give away
slow memory now. Yep.
Assassin's Creed Valhalla.
Ooh,
really nice.
How do I sign up for that?
Well,
I think you can still join.
Yeah, I better don't tell, because otherwise the other guys don't have a chance to win.
Exactly. Yeah. Gotta be here early. Early worm catching.
Yeah, we already some people know where to go. So before we start, I already see some entries. Only a few. Anyway, next winners. Let me see. Congratulations, Cap. Congratulations. We will send you a gaming code in the coming days. Also buy loyalty bonus. Nice. And at 55, Isaac. Congratulations as well. Let me go. Let me see which view. I have so many scenes today. Main view. Yeah. So if you still want to participate, go to amazon.com/do/insider. You can still join up. You need to perform some actions, and the more times you watch, the more points you get in order to claim the loyalty bonus. So basically you get a bigger chance on winning something. On Twitch and YouTube we also have a bot running. Each 5 minutes it will spam the link. And it will also spam the Gleam link, in case you're interested in that. So Ruud.
Yeah, the NDI is running?
The NDI is running.
But yeah,
yes!
There we go. Okay, what do you want to see first?
Well, you wanted to do some baseline benchmarks.
Yeah, I think we can show.
So maybe do 15, 20 and power usage?
Yeah, let's do that. I'll start with the 20. You can continue and we'll show the results in a minute or two.
Yeah, so let me... So we're now going to run these benchmarks, 15, 20 and 20 power usage. And maybe also CPU. And then we're going to do the benchmarks on... Ruud, you want to do the memory benchmarks and the crystal disk mass benchmarks with ABT or doesn't matter?
To be fair, I would run it without, but
okay.
I don't think it will matter for the disks. The disks will be as fast on. It will not turbo anyway. So,
this is basically a different slide saying the same like what Alex just explained about adaptive boost technology. To be clear, adaptive boost technology you can only find on 3. Let me see. 2.
Yeah, so the i9K and the i9K.
I have. Yeah, so actually it's 3, but they made a typo. They is like my colleagues. I didn't check it enough. Anyway, the slide says it can be found on i9 11900K. Then it should be i9 11900K. Is it KF, right? Yes.
Yeah, K.
Yeah, and then the W1390P, which is I think a Xeon CPU, which also runs in the same socket. And it seems we have BIOS support for that. But I'm not sure about pricing and etc.
Well, yep.
Yeah, so a little bit about the ABT, so the behavior regarding temperatures and voltages and the package power and voltages. So we had a diagram, and this is with the AVX power virus. So just to show the extreme case. Ruud, maybe you can explain a bit about this?
Yeah. The red bars you can see is Cinebench R23, which is just a longer version of the R20 I'm using. I just don't want to wait that long for a benchmark to finish. That's why I'm using the 20. And that's kind of a normal behavior program. And the power virus, in this case, I think they're using AIDA stability test with only the FPU running. And then the voltage will shoot up, and also the package power will shoot up. And of course the temperature will go up immensely. I also finished Cinebench 20, if we can just... so the score is 5903.
Okay, I
will drag it there.
I need to do my homework. So this is 20.
Yeah, R20 multi-threaded, so that's all cores loaded. 5903.
It's lower than the previous CPU, so...
Yes, it is, yes.
Okay.
But it's running 8 cores, and it's running at
about... That's true, and this is multi-threaded.
4.8 gigahertz. And the package power, maybe I need to zoom it and drag it somewhere.
Zoom, enabled.
The other one was around 220. This one is about 205. So it consumes a little less power.
And what is the all-core frequency?
4.8.
Yeah,
so 8 cores running at 4.8. So that's where you get the extra performance per core, per clock from. We'll see that with ABT, the performance will be very close to the 10900K.
Yeah.
But also the power will go up. I'll also run the Cinebench 15, the single-threaded one, and you can see where those improvements are made as well.
Yeah, so let me make this bigger. So we just filled in the 2 scores Ruud was talking about. So the default performance is lower, but that's logical. It's multi-core, multi-threaded, because you're missing 2 cores. So actually, percentage-wise, it's maybe impressive. Also lower power draw. So now Ruud is going to do a Cinebench 15 single-threaded. Let me check the chat, some questions. Merrick, so it's still advisable to use an air cooler on the new Intel chips in a non-air conditioned room. Actually, I don't think it really, I don't think it matters. I want to say, I think it depends on what you want. And of course with CPU, if you go for the 11900K, yes, you need water cooling, you need a 360 water cooling, and then, yeah, the sky is the limit.
Yeah. if you go like an i5, you can
Easy.
do any cooling would be fine.
Yeah.
Uh,
If you don't want to overclock.
Yeah, but usually if they have a K CPU, they just want to get just a little bit more extra performance out of it. So then cooling is a good investment, I would say.
Yeah, indeed.
So
Ruud, how's your benchmark?
Yeah, so-
sorry, Alex. Go
Still
ahead.
running, still running.
Oh, sorry. No, there was a question. Is like, which one is my favorite CPU? So I currently have a 10900K in here. But
I thought
one
you
of the
were going
ones
to say AMD. I currently have an AMD here.
sorry, it cuts out when you were saying what was
no.
what the three
No,
letters?
no.
So my favorite, like, so I have the 10900K, but one of my other favorite is the 10980X. The 1090XE. Back in the days, we have the high-end desktops, the whatchamacallit, the X, or the 299 motherboards, the X299 motherboards.
Cascade Lake X.
Exactly.
That's also one of the biggest and baddest CPUs, and baddest meaning very powerful, very mean CPU.
Yeah.
Especially in those days, it was awesome. Yeah.
Yes.
Yeah.
Yeah. Now it's an invisible pink unicorn. It's really hard to find.
I still have one.
Stu? I'm gonna go stop. Say hi. And run away with your system.
Okay, so the Cinebench one has finished, Eric. If you have time to write down a score.
One moment.
Okay, no problem.
So let me first write down the score. Cinebench, Ruud.
Yeah. There's always a delay when updating.
Because I think Alex also is running out of time. He will soon have to leave. Because you had another meeting, right?
Yeah, I apologize. I am actually, well, not to plug it, but I'm actually about to start running an AMA on Reddit on Build a PC.
Okay.
So I'll be there answering some questions.
So, Ruud, is this correct?
PC questions, not live questions.
Okay. So, Ruud, is this single-threaded?
Single-threaded, yes, 263. So that's quite a big uplift from the 220 we got earlier.
Yeah. So let me show that here in this overview.
Yeah, that really shows the improvement of what Intel did in the core. So that's really cool. It's really impressive.
That's really impressive, yeah.
What I saw in reviews, this will also pay out if you do Photoshop and stuff like that, because most of the things you do there is still single-threaded. Also in Excel and other Office kind of behavior. This stuff matters. Yeah.
Ruud, do you still have any questions for Alex? Otherwise, we're going to say goodbye because he's running out of time.
Not at the moment.
He needs to go to Reddit. He's a popular guy these days. I saw him last night as well.
Yeah, thank you. Yes, I was there too, trying not to stumble over my words.
So, Ruud, any other topics for Alex?
Not from my side, but
no, okay.
Just checking the chat room.
Yeah.
Not too much there.
Yeah, they had enough time. Anyway, thanks for your time, Alex.
Thank you guys.
Thanks for joining. Thanks for all your input and expertise, knowledge about this stuff. And maybe, I don't know, whenever something new will launch, but maybe we will talk to each other by that time.
Yes. No, I am. First of all, thank you guys for having me. I'm very honored. I have a lot of fun talking to you guys. Not only during the show, but also people don't know, but to preparing the show and everything. We have previous meetings. It's a lot of fun. I really enjoy it. So thank you guys. Yes. And even if you just want to talk about anything from movies to technology, I'm more than happy.
You're welcome. Thanks for your time and good luck with Reddit.
Yeah. Thank you.
Thank you guys. Have a great day.
Thanks. Bye-bye.
Thank you very much. And thank you to all the viewers. Thank you.
Take care, bye-bye. So I'm going to check where I need to go. I now go here, and then I'm going to hang up Alex. So Ruud, let's continue. So these are the benchmarks now.
Okay, what's next we're gonna do?
ABT? No, then you need to reboot, right?
Yeah, of course.
So maybe do first Watchdog. Then we finish the list.
Yeah, we'll do Watch Dogs as well. Watch Dogs, and we can also do the disk mark
Yeah,
if you want.
yeah. Let me.
And we
You
can
do
also
Watch
do
Dogs.
the USB. Right, the USB disk mark we can also do.
Because we are also running out of time.
Well, what time do we need to finish?
Oh, we have
In
so
15
many
minutes?
topics. Should we, Ruud?
Yeah.
Are you available next week?
No.
We have too many
Okay, I'll
topics.
fire up Watch Dogs, okay?
Yeah. No, maybe skip Watch Dogs.
No, Watch Dogs is interesting because
Okay.
it also scales with ABT.
Yeah.
So
Show Watch Dogs.
I did so much testing and
I know.
preparing, so wanna show this. I forgot what was the score of Watch Dogs.
One moment. Watch Dogs was 133 frames per second.
Let's hope it's better.
Should be.
Yeah, in previous testing it was, but yeah, it's like I forgot about the other SSD with Windows on it. You know, sometimes during live demo stuff goes wrong, and I'm the one to blame. So yeah.
Can we maybe already talk a little bit about Gear 1 and Gear 2?
Sure. Yeah. Basically, the Gear 1 and Gear 2 is just another tool like we also see on AMD with the Infinity Fabric.
It's strange. Alex is gone and you mention AMD.
yeah, it's not strange. But the Gear 1, Gear 2 basically relieves the memory controller to not run as high as the memory. So basically, the memory controller is under less stress and can run faster memory.
Mm-hmm.
So you will not run into that your memory is not booting because high frequency is you're testing high frequency, and then usually the memory is the culprit, not the memory controller anymore.
Yeah.
So it will just give you a tool, but running the memory controller in half the speed basically means that the latency will go up. The latency will, as you can see in the slide, up to 3600, same as with AMD, you can run 1-to-1, as you can call it, or Gear 1, as Intel likes to call it. With 3733 and higher, you need to step up to Gear 2, or it's very hard to run 3733 in Gear 1 mode.
Yeah.
So you need to step to Gear 2, or half the memory speed is used for the memory controller. But that will increase the latency, but it will still give you higher bandwidth or similar bandwidth compared to the 3600 in Gear 1. It's just if you're into memory overclocking, it's another tool you can use.
And what
to
memory
get higher.
would I need to buy for the best optimal memory if I look at this?
For me, I would say 3600 would be the sweet spot, because if you're running memory controller and memory 1-to-1, then same as with AMD, you will get the best performance for your buck. Anything above that is nice to have great screenshots. Oh, I'm running 4800 megahertz, but yeah, in the end, that kind of extra money you spend doesn't really pay off in benchmarks or games.
Can you explain a bit about this? Because it's big table. Should people worry about this?
What it basically says is if you're going above 18 a multiplier, or depending on also the bus clock, so the memory clock can be 100 or it can be 133. Anything above 3600 megahertz will be very hard to run in Gear 1 mode. So that's why all the higher numbers are turned red.
Yeah.
And with Gear 2 mode you can do that, but some options are not working because you cannot do odd multipliers. So you cannot do 17 divided by 2 for the memory controller clock.
No.
So 17, 15, 13, that doesn't work. So you need to have 12, 14, 16, and that will work. So you will have less options, but it will give you options to higher frequency memory without stressing the memory controller too much.
Yeah. And then this is the XMP what we are using on our motherboards, right? So
Yeah.
it's
So basically, 3600 and lower will use gear 1. You can switch back to the screen again.
This one?
To the
live.
MDI one.
The capture.
Yeah. So basically, what we see here is 141 frames per second on average. Also, the power was quite high, but also the CPU frequency was 4.8. It's dropping now a little bit because it's fluctuating because the load is not there anymore.
141 FPS.
Yeah. If you're running with ABT, and we'll show you then later,
Yeah.
the CPU will run higher frequency, but also higher power, and usually that will translate to higher frame rates as well. Or in this game, it will translate to higher frame rates.
I added to the table.
Okay, 141. What's the other thing we need to test? We're gonna do the disk thing.
Yeah, let's maybe talk about disk performance.
Well, memory. We were talking about memory. You can do the memory too.
Yeah.
Let's do
So
the memory
let me
first.
continue about memory. So this is the XMP rule we're using on Z590. However,
so, if you go into the BIOS, you click on the XMP, the BIOS will read the frequency your memory can run at. So if it's 3600, it will select gear 1.
Yeah.
If it's slower, then also gear 1.
Yeah.
If you put in 3733 memory, it will automatically select gear 2. So
and here you see the difference in benchmarks,
Yes.
basically.
and that doesn't mean you cannot try to run it at gear 1, but the recommended setting is gear 2 because it has more success to be stable.
Yeah.
And if you're overclocking memory, you can try anything you want, more voltage and relax the timings a little bit. Then you can also play around with the gear 1, gear 2 setting. But yes, the gear 2 is then the preferred setting for and XMP does that automatically, or our BIOS is doing that.
Yeah. So if you go to our BIOS and then you just you don't want to touch anything of these settings, this will be on auto, and you push the XMP button, you save your settings, it will run in XP mode, and everything will be done automatically in gear 1 mode.
Yeah.
If you're like a die-hard memory overclocker, or you just want to try, I mean, we have a lot of memory overclocking options in the BIOS.
Yes, yes.
Even we don't understand everything, so we need to talk with our overclocker. How does it work? And these are
the basics. Yeah.
And these are the latencies, right?
Yeah,
Yes.
these are the latencies measured in AIDA. That's also the one we're measuring now. The latency between the 10900K and the 11900K are not that different in gear 1 mode, but if you do gear 2 mode, then the latency will increase because the memory controller is running at half speed. You can also check in CPU-Z if your memory controller is running half speed or full speed. I'll show you in a screen, in a second. The AIDA benchmark is almost finished. You can write down the copy speed. The read and the write speed are not that much higher than the 10900K, but the copy speed is substantially higher. The other one was 47.
47355.
Yeah, and this one is 52507. So that's quite a bit better. Latency is a little bit worse, I would say, or higher. So higher latency means longer wait times, means slower.
What is latency?
48.8.
It's almost the same.
It's very similar, but it's same ballpark, I would say. If you're clicking, oh, that's the wrong one. Sorry. CPU-Z. I'm checking different software like AIDA, HW Info 64 we use a lot, and CPU-Z. CPU-Z is one of the few software that, oh, sorry, I should put it here, that can actually show the memory controller frequency correctly. So even though the AIDA has updated twice today already, so they're also updating that software very frequently, and so I wouldn't be surprised if in a few days time that AIDA is also reading the memory controller frequency perfectly. So here you can see it's around 1800 megahertz, which is the same clock as the DRAM. and you have to multiply that by 2 because it's DDR, so dual data rate, so it's running in 3600 speed, DDR4 3600. Also same as what is shown here in the AIDA one. The only thing AIDA cannot see is that the memory bus is running at 1800. If I put it in gear 2, it will still say 1800, which is not correct.
Ruud, question from anything under the sun. Does memory speed matter in Intel chipsets, or is it only in AMD chipsets?
Not sure what you mean by
I mean, does memory speed matter in
real world performance? Or?
Yeah, performance in games.
Yeah, it does. Yeah, especially in the for gaming, definitely the CPU bound titles it will help, but don't expect like a huge jump. But if you're trying to get the most out of it, every little bit counts, right? So yes, it will matter a little bit. Also, if you're doing video encoding or compression like zip or RAR or 7-zip or whatever, higher memory speeds tend to speed things up a little bit. Yeah. For rendering, it doesn't matter that much. So for that kind of workload, no. For games, some games respond well to memory. Also, we saw in the past that memory also can respond well to 4 DIMMs instead of 2 DIMMs. Some reviewers also explained that part. Yeah. I think that was on AMD as well.
Ruud, can you do the storage benchmark?
Yeah, sure. Then I should speed up as well. Yeah.
Yeah. Then I will continue about memory a bit.
Yeah. Sorry. Yeah.
So this is the memory benchmark Ruud was doing with the G.Skill Trident Z modules. Yeah. The big change in this generation is also that B560, the B platform, can now also overclock on memory. And depending on which model you have, the Mini ITX can go up to 5200 because of the PCB layers, and all the other boards can go up to 5000, let's say 5000. This of course depends on the memory modules, the quality, etc., etc. An interesting thing here in overclocking on the B560, because B560 platform, normally you can overclock memory, but you can not overclock the CPU. Still, what's maybe interesting for a lot of people, you can overclock the base clock. I know, probably you remember this from the past, 100, 101 with the multiplier, you can play with it. So we just took an example. If you compare the i9-11900F with the column on the left with the column on the right, 11900K. Both are running on a base clock of 100, and you see the benchmarks of single and multi-threaded. The 11900K is faster. It's just a little bit faster. But if you're now using a B560 Tomahawk, for example, you can also overclock the base clock just a little bit, and with that you can get more performance. So even more performance compared to the K CPU. So the F in the middle column is running 102.8, and you get a benchmarks of 635 compared to 628 on a K CPU. So basically you pay less because you have a non-K CPU. You have a B560 platform, which is not for overclocking, and you still get the same performance. And probably, but we didn't test this, or we don't have the data, probably our headquarters has this data, you get it for a lower TDP. Ruud, what do you think? For lower power usage?
I expect to be very similar.
Oh yeah, okay.
Yeah. Because the cores inside are not that different, the K or non-K.
Yeah, but what I was thinking, I mean, you're only overclocking the memory bus. You don't use all the other fancy dials and switches, which you have on the K.
No, but the regular turbo in the 900F will still be quite high and very close to the K, maybe even the same. I haven't checked, but probably is close to the K, maybe 100 megahertz lower. Yeah. But that 100 megahertz difference is now compensated because you are overclocking by 2.8%. So the 2.8% might be close to 100 speed.
No, somebody's depressed. The markets makes me depressed, yes. But hopefully this will be a matter of time and it's changed. Ruud, you did a memory benchmark?
A disk benchmark. So I took the the RAID 0 setup, so the two SSDs connected to the PCH, running PCI Express Gen 4, PCI Express Gen 3 by 4. So each can do around 3,500 megabytes per second, and if they're paired with a Rocket Lake chip, which means the bus between PCH and the CPU is running at by 8.
So that's this part. I
That's
now
that
put it on
part,
screen.
exactly. Now it will also show that those two drives can combine that kind of speed into 7 gigabytes per second. So that's almost double of the 3550 we had with the 10900K.
So that is, let me take my number slides.
Now we also see another drive pop up, and apparently Windows is installed. Sorry for that was causing the blue screen, so this installation doesn't run on this platform. So my mistake. But this CPU, this SSD is connected to the CPU, so it's running in PCI Express Gen 4 by 4. So this should have very close or similar performance as two drives in Gen 3 by 4.
Yeah, so now we're talking about 11 Gen,
Yeah, so I'm
the
just running
ML2
that
connected
one as
to the
well.
11 Gen.
Oh, that's the wrong one, sorry. I need to select F. Why F? Why not
Nobody
E?
saw that, Ruud, because they see this slide.
Yeah, I know. You can switch back to the NDI one. Then.
Yeah,
You
so
can see what I'm doing.
this is the benchmarks we just got with the DMI.
Yeah.
So Crystal Disk Mark DMI 3.5 gigabits per second versus 7, and that's because of this bottleneck. The DMI bottleneck, let's say, is removed.
Yeah.
And what
it's
you additionally get, you get an extra ML2 slots which runs Gen 4, and that's what Ruud now is also benchmarking.
Yeah, it's close. It's 6,800 megabytes per second.
Yeah,
a little bit more.
So that's close to 7.
Last time it ran even higher, but yeah, 6, 8.
If
6,
you run
9.
this 10 times, you get 10 different scores.
Yeah, that's true.
Yeah.
So this is really fast, and this also means if you would be in a position to have like a very fast Gen 4 drive, and you have two quite fast Gen 3 drives as well, you can move data around very, very quickly, a lot quicker than you could if they're all connected to the PCH. This is basically what we also demonstrated on the B550 Unify with the AMD one. This is close to that same performance.
Yeah.
Only AMD had more lanes on the CPU to do that. More Gen 4 lanes to play around.
So Ruud, maybe you can reboot and we test ABT.
Yeah. Should I do the USB as well?
Yeah, you can run that. Yeah.
Well, before with the Z490, we need to use an additional chip on the motherboard. We used an ASMedia ASM 3241. Yes, that's correct. So this is the SSD connected to the CPU. This is the RAID set, so two SSDs connected to the PCH. Now I'm going to run the E drive, which is not seen because I plugged it in after the program was loaded.
Cannot refresh?
No, I don't know where. So I'm just restarting this quick. So now I'm using the Western Digital P50. That's this one. And that's the external USB drive. I'll show you it's very fast as well.
You have the box over there somewhere, right?
Yes, somewhere.
Oh, it's yeah, there on the right, behind the monitor.
I'm still wearing my earbuds, but it's not necessary anymore. Anyway, this one is the box of the P50. You can switch back if you want. So it's doing an external drive doing exactly like 2 gigabytes per second, which is really amazing. And
This is also quite interesting because if we look at the ASMedia performance, which you see here on the screen, it's 1653.
yeah, between 16 and 17, that was what we got most of the times with the exact same drive. So it's the Western Digital P50 again. So yes, it's quite a increase in performance.
Yeah. So because this is set for 90. Set for 90 didn't include any USB 20 gig from Intel.
No.
So we needed to use an additional chip, and these additional chips, they're always bottlenecked by PCI Express lanes. So basically, you don't get the performance you want. So this is USB 20 gig on an
It's
AS media.
still fast, but yeah, there's more.
It's a lot faster than 10.
Yeah?
Yes.
Yeah. So if you pay for this kind of drive, you also want to have the maximum performance. Then C590 will give you that.
And then because we talked about why upgrade to this platform. Of course, if you come from a 10 generation, no use.
No, probably
maybe
not,
9 even not.
No, I think 8 or earlier, they will definitely gain a good performance increase.
Yeah.
And yeah, that's where you have to look at. Yeah.
Indeed. So.
Okay, almost finished. So yeah, this is the one. So 2 gigabytes per second for an external drive. I think a lot of people would be happy if this kind of speed was inside their system. So
Gigabyte with a big B.
yeah, 2 gigabytes. Actually, I'm not sure if it's 1,000 megabytes, or yeah, I would say, is it 1,000 times 1,000 being a megabyte, or is being 1,024 times 1,024? No. Then it should be a maybe byte or GB byte.
Maybe byte, yeah.
It doesn't really state that very clearly. So ABT.
Yes, so
Let's
you're
do
going
that
to
one?
reboot with ABT, right?
Yeah, you need to go to the BIOS and enable it. You should have a screenshot of where you can enable it.
Yeah, let me quickly show the scores we have up to now. We ran resize bar with Assassin's Creed Valhalla. With resize bar, we got a score of 128 on the 10900, and we got a score without of 180 FPS. And of course, I mean, we didn't run this on 11900K since A, we don't have time, and B, no difference. I mean, yeah, there can be a difference, but it will be very small. Cinebench on the previous CPU single threaded, so Cinebench 15 is 220 and 263, so a big jump on the single threaded performance. Cinebench 20 multi-threaded, 6000 on the 10900 and 11900K, well, they both have a K, 5900. Yeah, I mean, it's a 2 cores less, so it's a 10 core versus an 8 core, so it's logical, but still because of the higher single threaded performance, it comes close. If you look at power draw, and this is multi-core Cinebench 20, 220 watt versus 205 watt, so I think this is all pretty okay. Watch Dogs Legions, 133 versus 141 FPS, also nice score. But of course, I mean, we just picked some benchmarks. If you check your favorite reviewer.
I need to mention one thing, that's the multi-threaded scores are lower than if you would run it without any programs in the background. So I'm running NDI in the background. I'm also running HW info in the background, which steals CPU cycles. So that means that the scores will be a little bit lower. Also for Watch Dogs Legion, the performance in pre-testing without any NDI and without HW info and without Afterburner and without Riva Tuner overlay will run a little bit faster. So keep that in mind if you see this score.
Yeah, this is just
it's not that high.
No. This is just to compare. Because this is just to compare the 10900K versus the 11900K in the same conditions here.
Exactly.
We did it
so
live.
Both are run
you did
with
it
NDI,
live.
both are run with HW info in the background, just to show you guys what's going on and what kind of power draw it does, because that is kind of interesting with ABT. You can already switch back in a second, I guess.
Let's go to the DMI benchmark. So 3.5 for 2 drives versus 7 gigabytes per second. Very impressive, and that's a big bottleneck removed. However, please keep in mind only 11 gen CPU plus Z590. You don't get this on B560 or H510. AIDA memory score. Interesting. I mean, that's almost 10%, right? If
Yeah.
yeah, indeed. So
Yeah.
nice jump.
And that's with the exact same timing. So the same memory speed, same timings, you still get an increase. And that's the copy one, which is probably the ones telling the most. The memory and the memory read and the memory write were not that far off, but if you combine those together, then you will see the difference.
Yeah, indeed.
So
and
that's
then
the copy one.
we have the USB 20 gig, maybe should be G, 1.6 on S Media on Z490 and 2 gigabyte per second on 11900K. Let's say just the Intel
on Z590
500 series.
native USB 20
Yeah.
gig. Yeah.
Yeah. So Intel did a nice job over there, and now we're going to benchmark ABT. Ruud, you're up and running.
We're up and running, so now it's just.
Just the NDI we still need to get working.
Yeah.
Always.
I'll capture mouse cursor. Does that help?
Oh yeah, those kind of things help.
Sometimes there's a delay, but this is.
1, 2, 3. You're running NDI?
Yeah, it's running. I selected mouse cursor, video bandwidth high.
If I enable this one.
Shall I restart mine?
No. Well, what? NDI or the system?
Yeah, it can be anything.
Maybe NDI again?
Okay, let's exit.
Sometimes it works and sometimes it doesn't.
Yeah, that's why you need the capture card.
Hey, hey. People are talking only for with AMD CPUs is there is no iGPU. They have their APUs for that.
I'm going to restart the system.
Oh, yeah, sure.
Yeah.
Then I go back to this slide.
I'll unplug this one.
I'm going to do another giveaway, right? Should I? Well, this is the last one today. Otherwise I get in trouble. Probably. The next winner is JP, I guess. JP, congratulations. Yeah, JP, simple. In the coming days, all winners will get an email from us with a Assassin's Creed Valhalla game code, really nice game. Yeah, for next week we will see what we're going to give away. Not sure about that. Reboot ready, Ruud?
Yeah, is it up and running? NDI, check NDI.
Hey, yes,
Yeah,
it
looks
works.
like it's running normally.
Fixed
Yay.
it. No, not JP Morgan. JP, just with a lot of ease. Okay, so now we're going to run ABT.
Yeah, ABT is already enabled, so you should see higher turbo speeds already in the HW info. And normally we have to wait a little bit before Windows settles down, otherwise that will influence the score. You can see that there's some extra. Of course, this one has 2 cores less, so we don't need to show the bus and stuff. So now it's running normally. It's 3.5 gigahertz instead of the full turbo. That means Windows has finished loading all the stuff in the background. So I'm just going to run Cinebench, and we'll keep an eye out on those power draws, because maybe you've already seen in reviews that people claim that this CPU runs at 300 watts. Well, if you enable ABT without any limits, they're right. It's running at 303 watts at the moment. So
303 watts. Wow.
yeah, that's quite a bit, you know.
I go to my table.
And 5.1 gigahertz on all cores. That's what ABT is trying to do. And if you're running unlimited, it will do that exactly. But you need to keep an eye on those temperatures, because if your cooling is not up to it, then yeah, things overheat very quickly with 300 watts. So it finished, and it got 6260.
6260. Okay, I'm going to...
So that should be very close to the 10900K, but it also consumes way more power.
Okay, and it was 300 watts, right?
Yeah. 303, I would say, but yeah. Not sure if that matters.
Actually, it should be big W, right?
Yeah.
And what is the all-core?
The all-core is 5.1. So all-core is running at 5.1 gigahertz when the load was applied. So after the load is finished, then it will go lower, of course.
Yes,
Also
I put everything in a table.
So, is it ideal to run it at 300 watts? I would say no, because yes, the performance will be close to the 10900K. So with two cores less,
you can see it in the table.
Yeah.
It's actually better.
Yeah. Okay. But
Or did I make a typo?
no, that's correct. That's correct. Yeah. But if you run it without anything in the background, it will be very close as well. So I would say it's a tie.
Yeah.
Let's go to the watchdogs, because we should be able to see some improvement there as well. So
Okay. So basically you get like the same performance as a 10 core, but for 100 watts more. So 50% more power performance, power increase.
Yeah. So yeah, 80 watts more. That's quite a bit. So it's not an ideal situation.
No, it's not 80 watts. It's 100 watt, because it was 205 watt and 303.
Yeah, but the 10900K is doing 220 watts.
Oh
right?
yeah, indeed. Yeah,
So
yeah,
if
you're
you
right.
compare
You're
that
correct.
way,
If you
then-
look at like
yeah.
that, correct.
Did I click the watchdog? No, probably not. Or Ubisoft is messing up again. Oh, anyway, yeah.
I got a Steam gift code from last week live stream. I have a problem with code redemption. Should I reply the email? Yes, just reply the email. You will never hear from us again. No, I'm joking. No, just reply the email and we will take care. We will contact you and see what the problem is and how or what. Yeah, sorry, I switched to...
Yeah, the game's still loading, so hang on.
So
you can go to the ABT slide with a screenshot. Do you have that one with the ABT enabled and enabled 251 watts?
I have.
Remember which?
Yeah.
Yeah, I can also do that later if you want, but
There is no
that
later.
one,
Good.
yeah. Intel Adaptive Boost technology on the right of the slide, you will see it says disabled, which is the default, then enabled, that's what I'm running now. And there's another one which they introduced the BIOS in the BIOS from last Monday, so I just got it 2 days ago. And they say, oh, we have an enabled 251 watts. Why 251 watts? Because that's the power limit of Intel's spec, or no, recommendation I should say. It's not spec, only ICC Max is spec. But it will limit the power too much, so it will want to draw 300 watts in Cinebench, but actually it only gets 251 watts. So it's bouncing between 5.1 gigahertz what it wants to do, and it's bouncing between 4 gigahertz. So it's going up and down all the time, meaning that the performance will be hurt by the switching of the frequencies
Throttling.
a lot. Yeah, it's throttling, it's power throttling at that moment. There is a way to have almost the same performance and still cap the power on a reasonable level, and that's run ABT with the current maximum of and current being the electrical current 245 amps. So that's the Intel spec way. So I think that's the better way to run ABT. Well, let's first do the unlimited one. Watch Dogs has started, and let's run the benchmark.
Ruud. Let's check the time.
What?
Time. It's almost 7.
Almost 7. Can I run this benchmark?
Yeah, this one you can run, but I mean, I'm sure security will and kick us out of the building.
We still have 8 minutes.
What?
We still have 8 minutes.
Oh yeah, no problem.
So if you look at the overlay, it's running at 5.1 gigahertz on the bottom left, and it's doing about 180 or 190 watts in game. That's a lot, but it will increase your performance.
F22 Raptor is saying, I think the 11400 is the best value. No, I think the 11600 is also very interesting.
I think 11400 will be also one of the top selling ones because it's more affordable, and if you're going to be GPU limited in most games, then there's no reason to go for the 600K. Or even go with the 600 non-K if that's available, but usually those prices are very close.
Yeah.
Or 600KF could be a good deal. Depends on what's available.
Nice work on your overlays. Somebody noticed.
Oh,
Ruud
thank
spent,
you.
Yeah,
I did
Ruud
a lot
spent
of time
5 weeks on
that
this.
Yeah, thank you. Yeah, I was trying to make something nice for our software team, and
how did you do this? With some overlay editor or something?
Yeah, inside Riva Tuner statistics server, you have an overlay editor, and it's explained by the programmer. Unwinder is his nickname.
Yes, Unwinder. Yeah.
It's not that much faster. It's only 142. So we got 141 on the last one. So
you still remember that? You're
think,
correct.
Yeah. But when I ran it before, it got 148. So I was expecting something similar to that.
7 frames more.
Yeah, but the ABT this time didn't pay off. Maybe maybe this benchmark is fluctuating more than I was hoping for, but that's possible. We still want to do a recommendation, right? So this setting is unlimited. I wouldn't recommend it. I would go for ABT with a current limitation. So if you do that, then ABT is good value, I would say. Or do a manual overclock, but it's going to be hard.
So now you're going to limit it to what?
245 amps. So that's what's just above my head here. Right?
Yeah. Indeed.
I think that you can even increase it, but 245 is the Intel spec, and it works well. It works quite good, and you can also raise it to 255 if you want. That's the maximum, because if you enter 256 it will be unlimited.
What do you think about the temperatures in the new CPU cores? I don't think temps are an issue. I never think temps are an issue if they're reasonable. It's about the heat they generate.
If you do ABT unlimited, then I think temps will be hot inside a case. I mean, I'm running here in an open test bench.
Yeah, let me
the temperature
show
here
this.
inside is not that hot, so I can cool that with a 360 radiator. But if you're putting it inside a case, I think 300 watts on a small CPU like this, it's hard to cool, or it's impossible to cool. So that's why I would recommend setting the current to a limitation. And I'll fire up, I'll first check if NDI is working.
Oh.
Otherwise, we have to restart.
Yeah. It's working.
Yeah. Mouse cursor, okay. And then I will just start hardware info. Yeah. Looks like it's sometimes missing some frames, or.
Lion King, you're saying you won last stream. Let me check who won last stream. Gleam. Anyway, better to send us an email. And no codes. So Ruud, maybe you can explain what you're doing?
Yeah, I'm waiting for the
waiting.
Windows to settle. You see the max CPU thread
24th.
is still doing stuff, and then also I see the cores being high, so the high frequency, meaning that it's not getting idle yet. Oh, here it is, the first moment of idle. So then we run Cinebench, otherwise it wouldn't be apples to apples, because background tasks are being completed. So let's go back to the HW info while it's running. And before we saw 300 watts, and now it's getting closer to 265 watts. And that's because I limited the ICC max current to 245 amps. So this is like normal. This is still quite high, but it's manageable power, and it's also manageable heat. You will see that the clocks will fluctuate a lot more, but not as extreme as if you would power limit it. The power limit will be very harsh. It will be go down by like 3.4 gigahertz. Now it's going down to, I'm not sure exactly, but what's this dip? It's 4.6. This dip is 4.4.
So everybody sees?
So it's already finished, and it's 6051 at the moment. So it's in between the default bias settings and the ABT one. And I got a little more last time, but for the all-core frequency, it might not be that interesting, but for the gamers, games usually don't load all cores to the maximum, but load all cores to like 40% or 50%. That's a normal use case.
So this is just to show a reference.
Yeah.
So you did 6,000?
Now it did 6,051.
With how much power?
265.
Okay, yeah.
So it's within manageable limits, and you can do that kind of speed with a high-end cooler. So that's possible.
Yeah.
Now, also a benefit of this limitation is that if you run any of those power viruses, it will be capped immediately, but still you will get high performance and AVX loads that don't load AVX units that much. So if you do Blender, for example, because that uses AVX, it will still run very fast, because the power is not as high as the power viruses doing all the AVX.
Hey guys, I'm going to stop our benchmark monster because it's 7 o'clock.
Oh, but I still had Gear 2 to show. We ran out of time.
Yeah, really. Because I don't
we
want
should
that.
have saved the resize bar for latest, because that was the least interesting, I would say.
We
But
can
anyway.
do next week. I can ask Peter next week to do resize bar because...
No, the Gear 2.
Oh, the Gear 2.
Yeah.
Yeah, because we don't have a topic for next week.
Oh, okay, yeah.
That's the easy thing. Anyway, H510, yeah, we already talked about it, I think 4 weeks ago. Yes, it's already launched. But I'm not sure when it's actually on sales with the entry-level CPUs, because normally first the high-end ones will come. Do you think there will be any improvements with BIOS updates?
Definitely, yes.
Sure, but I mean...
But especially on the ABT part, I would expect. Our ABT is working, and you can play around with that. It's not enabled by default, and it's definitely not putting 1.6 volts like other manufacturers on the CPU. So I think our BIOS is already ready.
Alpha, I was waiting for Gear 2.
Okay.
Sorry, we really run out of time. We have too much topics to talk about today. Anyway, let me see, probably Alex is here in this next week's slide. Yeah, anyway. Hello Alex. He is now on Reddit, so please go there if you have still any questions for him. For us, thank you all, we're going to run.
Thank you all.
Yes.
Thanks for watching.
Thank you Alva for helping us with the video. Thank you all.
Thank you.
Take care. See you next week.
Bye-bye.
Bye-bye. Hurry, 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 hurry.